Alright, hello. Welcome back. I'm continuing a little bit this session with making the scripting language here. AI has been refreshed, so I have a little bit more power to use it. Currently I'm adding some debugging information to more easily debug the parser. Just gonna check how much left I have. Feels like the AI is like using a lot more than it used to. I'm not sure if they lower the rates. Like it's so hard to see how much you can actually use it through the interface. But yeah. I'm just letting AI do its thing here. Let's see. Okay, there we go. It's done. So let's see. Stores active breadcrumb. Blah 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 blah. Right. Yeah. So I've been basically when I started this project, I just let AI do whatever it wanted, and I barely checked in on the code. I basically never checked in on the code. But now I've realized that that was maybe a bad idea. So I think it's like you have to sort of guide it a lot more, but it was a test, so you know, the more you learn. But yeah, so and also it's also you know, a mix between being able to communicate correctly with the AI as well as you know, checking in what it's actually doing and setting it on the right path. And also another thing is like when you let the AI just do everything, that is like a much more of a hurdle to actually go in and look at the code and try to do stuff yourself, because you have to sort of, you know, read everything, like understand the AI's code. And yeah, that's also like more of a hurdle. If you're like doing it yourself, you can just go in and, well, I mean, it's like reading someone else's project and you know, getting to terms with what's happening. So it's like basically no difference between that and this. All right, let's see if we can see what it's doing here. So all right, so it revamped this. So okay, so what I've been doing here is I've been implementing a breadcrumb so that we can see more easily which parsing we're currently doing, and when there's an error, it will spit out, hopefully, which parsers that were used. So here, for example, I'm trying to run this test file, and it says that it failed to parse on this line, and it expects like a string literal, but I don't know which parser it's currently like using to try to read this string literal. So what I will do is I will build, run this again. Okay, now it seems to have been fixed. So here we can see we have expect a string literal while parsing. So we have parse script, that's the entry point, so that's always going to be there. Then we have parsement, yeah, so these ones are basically always going to be there. And then we have parse statement, parse expression, parse identifier expression, parse pipeline, parse. So yeah, so the expression is just a generic expression. The identifier expression is an expression that starts with an identifier, because that could either be like an assignment, like you have an identifier equals something else. You can have like a modification, I don't know what they call, like modifying assignment, like or you know, plus equals, minus equals. You can have, yeah, just, you know, element access in an array. You can have, you know, anything that starts with an identifier, but also crucially a pipeline or a command. So pipeline is basically just a, you know, it's like this. This is technically a pipeline in the language, because it's like, but really a pipeline consists of many things like this. So if I want, so this is a pipeline with 2 pipeline stages. So we have this one and then this one. Okay. And then when we're parsing a pipeline, we're basically parsing until we're parsing first an identifier, then a bunch of arguments, potentially. And then if we encounter a pipe, now we know we're at the next stage. So then we can start a new pipeline stage. But apparently after we do that, we get this error. So we get expected string literal instead of an identifier. So here, the pipeline stage apparently tries to read a string literal and it fails. Of course. Also, it's kind of weird that it's here and not like here. So I think it's like a one-off error. Maybe that it's pointing to the space there. I mean, yeah, it's probably a one-off error, since the space white lines or right space are actually skipped as tokens. They don't even show up as tokens. So I think we need to like. Okay, so it could either be the pipe or. Yeah, it could be the pipe actually. That is the issue. So I think it could be that. So let's go to parse pipeline stage. Right. So here we are getting an identifier at first, so that's good. Then we're going into this loop where we are building arguments to the command. So we have this command here. I think I would whatever. This is so much, there's so much nesting going on here and stuff, so I wanted to clean it up a little bit, but whatever. So here we have like, if we have right parents, brackets, comma, new line. This should also include a pipe. I think that's why we're getting this error. Like, we're not really checking if we have a pipe here. So we should include this here. So we should have a pipe. Oh, there's a separate thing for pipe. Okay, well, pipes. I guess pipes are also like pipe. I mean, that's more like, yeah. I mean, that's like a. I think that's an and, or I mean an or. And then we have like ampersand. I guess an ampersand is also, you know, because an ampersand denotes that we are well, in Bash it's like an async, or yeah, you're a background task. Okay, so all of these should end the pipeline stage. Okay, I think that should be good. And then it goes back to over. Also, we could probably get the function name instead, maybe. Is that possible? Whatever. Instead of like doing that, parse pipeline stage. Yeah, so here we have the pipeline. I'm gonna move you here, and yeah, because that's supposed to be here. Parse identifier expression. Here we have a bunch of different things. We want to check if, yeah, all these different things. This should also be like the same thing. We should have like pipe. And really, this should not be just an identifier. This should be like a pipeline stage. Actually, I think we just parse a pipeline here. Actually, yeah, I'll do this. It doesn't make sense just to have an identifier. We need to have some sort of analysis on if we're trying to run a command or if we're trying to do something with a variable, because yeah, it's different. Okay, and we don't. We just want to consume that. There we go. And oh, I guess we do this. Okay, actually, we'll just do this. There we go. Yeah, we're just, the only thing we're doing is parsing a pipeline. There we go. All right. So we're parsing a pipeline. So the pipeline is calling parse pipeline stage while this is true. So we're getting one stage in. Now, if we encounter a pipe at the end, we continue with the next stage. It's gonna be interesting. So the stages, so basically it could be different. There could be different things happening in the pipeline. What about, you know, anding and oring and stuff like that? That's its whole thing here. Payload, role. I guess the expression, command invocation, redirects, capture, background span. Because yeah, if you have an expression that is like echo cat, like that is just a normal pipeline. This is one stage, this is second stage. However, you could also do this, and then it's not really a pipeline, I guess. It's more like two different statements. However, this one depends on this one. So I guess this is not technically a pipeline in that case. It would be more, I'm not sure if we actually got to implement that here. I don't think so. Okay, I'm just gonna ignore that for now. All right, so but yeah, let's start with this one. So now we're doing that, we're checking if it's a pipe, then we continue to do the next one. Otherwise we should end it basically. We create the whole pipeline and we are done. All right, now let's test this again. Okay, there we go. Huh, we get, oh, now it says expecting identifier. Okay, I think it's a case of actually consuming the pipe. We should consume the pipe here and then continue. And we continue. Actually, which last token? Okay, this is where you can use continue expression here. Last token equals the next token, so that each time you continue or the while loop falls through to the next iteration, this expression will be called. So I don't need to like type this in again here. Oh, we got some issues. Undeclared identifier next token. Ah. That is interesting. I mean, it does exist within the scope of the while, but not outside. So does it has to be outside the scope? Because that's curious. You would think it would have access to all the things that are in here. But okay, I guess we can fix it by just putting next token over here. It's a bit annoying, but fine. and I guess we'll start with start token. I'm not sure if this runs. This should run at the end of the iteration, not at the start. But just to make sure, I'm setting it like that. Okay. Okay. Unexpected character. A character. Right. This is actually pretty interesting because I didn't actually think about this. Well, I don't think we should consider using single quotes as characters or just one byte. I think we should consider them being just a string type as well, because it's gonna be like more like a scripting, you know, language. Actually, maybe we should enforce that, but I'll just switch this out for now. Okay, there we go. It works. I just realized what it's spelled here, but okay. Okay, cool. It does work, right? I don't think interpolations work though yet. It works in the. No, it doesn't work. But we're gonna get there. So it was implemented in the previous parser or in the previous thing, so it should be. You know, we should be able to get some inspiration by looking at the previous code that the AI has spit out. Okay. So now the pipeline actually that now works. Okay, cool. What do we want to do now? So should we just get to the interpolation maybe? We have the parse string literal, which is right now we're just allocating one segment. So basically a string literal consists of segments. You would have you know, a string and then interpolation variables or interpolation expressions and strings. So so you would go through each part here. So the first one, so this is one segment, it's a string, and then this one is a separate segment here, and so on. So so what is the token? The token is a string literal, I think, and let's see, token. Yeah, so the lexeme is like the source code basically at that point. Here we're checking if it's more than 0. It should always be that. But whatever. So we need to look for. I mean, let's just try to do it manually here. We should just look for like interpolations here, so we can make a split iterator. Let's make also the segments. We need to make them different. So let's make an array list of segments, and we will initialize it at the end, and we will copy it later. So let's remove this here. Okay, inner. So the inner is basically okay, that's the thing we want to iterate over, and then the segments here needs to be copied. So this is going to be copied to arena segments.items. There we go. Okay, so that part is done. Now the only thing we need to do now is we need to create a split iterator, I think. So we need to have a split. And let's see, how can this work? There's also things like tokenize. I'm not really sure what the difference is. Turns iterator, iterator. Returns an iterator, iterates over the slices of buffer that are not delimiter. Will return slices. Okay. If buffer is empty, iterator will return null. Delimiter 6. Okay, well, what's the difference between this and like split scalar? A split scalar is only like one delimiter. Tokenize scalar, it's also one iterator. It turns iterates over the slice of buffer separated by the delimiter. Will return slices in that order. The delimiter does not exist the buffer. Yeah, so what is the difference? I don't understand. I guess, okay, I guess this one actually, this one like it skips over empty stuff. So in the other one you had like two delimiters side by side that produced an empty string as one of the splits. This one just skips all those. I see. And that's convenient actually. But actually I want to have, you know, it's gonna have to be maybe we don't use a tokenizer. Maybe we just keep some state, we loop through the string and we try to parse it that way, because it's gonna be a bit more complicated, because I don't think there's like a built-in for having like, you know, an opening and a closing thing. So I think what we need to do is we need to basically, we're gonna loop through the inner array. So we're gonna have, I'm gonna call it C for character, I for index, and we're gonna need to know if we're currently in expression. Whoops. If we're in an expression or not. So we start out not being in an expression. So we're switching on, actually let's do like string state here, enum. So whoops. So either we are in an expression or literal, I guess, or string, I guess. And then we have the state starts out as a string. So we switch on the state. Oops. And if we are in a string, we want to look at, we want to switch on the character. And if we have this, so I guess this would be like start expression. Also we have start expression, and yeah, if we have this, we're gonna set the state to start expression. If we have this, this should, no, that should just be like part of the string, I think. So basically everything else is probably just gonna be put into the string. So I'm gonna have previous. So I'm gonna have like I want to keep an index to where the current expression or the current state started. State start is 0. Okay. Yeah, whenever we switch the state like this, we also change the start of the state, and we make a new segment. So we need to append a new segment, which is a string, and the string is gonna be inner state start to I. There's something wrong with it. Okay. There we go. Start expression. Oh, there we go. Okay. A little bit nested here. I'm gonna let's shrink you down a little bit here. All right. Okay, so if otherwise we just continue here. Okay. If we're at the start expression, we will look at this. So if we only have a quote unquote naked $sign, we probably, yeah, we just want to continue with a string actually. So we'll actually go back to the string. But if the only thing that's gonna happen here is if we have this. If we have this, then we will start, oops, we will go to expression, and we will, we won't change state start. No, we could change the state start. Sure. And it's basically going to be I plus 1, because that's where the actual expression will start. I think. Wait. Yes. I should be the current one. It should be 0. If this is like 0, then the start will be 1. Yes. Okay, and then we continue. If we get anything else, that means we have a naked $sign. So we should actually backtrack this to whatever it was before. Actually, maybe we don't actually modify state start here. Actually, let's do that, because it's like a trial here. We might need to make a new state, or we might not. So actually, we should remove this and put this here. Actually, yeah, there we go. And then you have to be like -1, because we had the $sign from before. Okay. So here we know that we actually have a new All right. Now what we could also do here, this is kind of interesting, because this is a good candidate for a labeled switch actually, but I don't know, it kind of makes sense that we have a for loop as well, because we're supposed to loop through the entire string. So, but you could make a labeled switch here. That kind of, it works like a state machine. I mean, we have a state machine here, but a label switch works really well with state machines, because if we're doing this, we could also say continue. You could say continue state start expression, and it would actually go back to the switch, except you have to have like a label here. So this would be, I don't know, label S. So continue S start expression. That will go back here, redo this switch, but now the state is actually start expression, or well, the state is probably not start expression. This would be like the starting point. Like you would do something like this. So you start with string. So we go over here, and then you have this one. This goes to start expression. Otherwise, we will do something here. However, then you have to keep track of the I yourself. So the I, you know, we need an index, which is why making a for loop, I think makes more sense here. But yeah. Anyway, so it's just nice to, you know, consider those things. Okay, so let's see. Start expression. Yes, we append this. The string part is done. We start an expression. I think this one is done. So if we have a naked $sign, or I don't know really what this is called actually, this special, would be nice to know that, but whatever. I'm gonna call it a $sign. Start expression, then yeah, then we just continue with the string, and we don't actually do anything like, no. What we do actually, because now we're in the start expression state, so what we need to do is just bring this back to the string state. So yeah, so now we're going back there. So that should be down there. Now comes, I think this could be the most complex part here, maybe, or maybe the easiest, I don't know. But basically we need to parse an expression. However, we need to also find, I mean, this is kind of interesting because we have this string. We know that the expression should end. Actually, you know what? Maybe we could just parse this as a block. We could parse it as a block, because then it would include the curly brackets. Or, well, a block. Okay, so a block actually has statements in it, which is probably not what we want. We want to have an expression. So let's make a parse block expression actually. Yeah. And it's not really a block. It's gonna be an expression. There we go. It's just parsing an expression, but we know that it's gonna be a block. However, this doesn't really work though. No, it does work. I wonder how this token works, because we won't allow. Yeah, the thing is that the string literal, this whole thing is one token, but maybe it shouldn't be actually, because it's gonna be pretty. I don't know. The problem here is that this could be any kind of expression, so we could have, you know, even quotes in here as well, and it should work. Like you could do this, and it should, like, you know, be an expression where you could have quotes here. So that's the thing, like this is not a token here. This whole thing should then become a token, or we have this as a double quote token. No, wait, that doesn't make sense. Or this could be like the first, like, string start token, and then interpolation start token, and then we have a bunch, and then we have like a bunch of normal expressions. I don't know, man. Because this only should be interpolation start token in a quote, or should it? Man, this is starting to get a little bit hairy here. Well, I should opt going for the easiest possible thing first, I think. But still good to go through like different options. Okay, let's check. Whoops. I'm gonna check the lexer on string literals. String. I've never looked at this, by the way. This code here. That becomes a string, okay. And then we're looking for a double quote. The thing is here, like if we want this to be one token, we basically need to embed the whole expression logic in here, like parsing that. It's probably better to have those as tokens instead, probably. I don't know, it just feels like maybe the parsing will become easier, or the tokenizing becomes easier at that point. Because otherwise, if we embed the whole the expression tokens in here, and then this whole thing becomes one token, we need to, well, either we could provide this thing in the token, or we could just say that, hey, this whole thing is one token. And then you need to actually look in here and parse this. You need to tokenize this as an expression later as well. It just feels like we're doing a lot of unnecessary work. It's probably better to tokenize this differently. So this would be like the start of the string. And then you would have a token here for start of an interpolation. And then here's like normal expression tokens, whatever, and here's marks the end. Well, this is just a right curly bracket, and then this one is just a closing double quote. But then we would need to allow for closing double quote. I mean, that's fine. A double quote should be okay. So basically, maybe just the problem is with making double quote a token itself is that here we have double quote, and then this would be interpreted as an identifier, which is wrong. So I think if we encounter a double quote, we should end at a $, or those two together, and then this would be like start string or something. And then we continue. And then, but then we encounter this. How would this work then? Because then it would like interpret this as the start of another string. Yeah, that doesn't make sense. Yeah, this is complex here. Maybe we should embed the whole thing as one token, and then this would be like a sub token or something. Yeah, that's way more complicated than I thought, actually. It makes sense that it is complicated, because technically you could have nested however many you want in here. And it's going to be hard to know where it starts and ends without having that whole logic in the parser. I think maybe we'll do it like this. If we encounter a double token, we'll start with this with a string. If we encounter any $sign this in the string, we will recursively, we will actually create a new lexer, maybe even. No. Man, this is hard. We don't really need to create a new lexer. We just need to wait, hang on. I'm just thinking about the internal, like the internal data here. I mean, technically we could create a new lexer, and we could then sort of merge these things, I guess. Well, it just feels maybe unnecessary. If we could reuse the same lexer, yeah, we should probably try that first, actually. All right, so let's see. Okay, so at this point, oh, 1 second here, sorry. Oh, sorry about that. I got a call here. Let's see, let's continue. So what I'm thinking here is, okay, so in this case, we just have a normal string without interpolations. And here we have some kind of thing here, like escape thing. Or we could get an interpolation, but we also need to check the next one. So let's see. So where are we? We're advancing here, so we should be able to peek and so if this is this and this is that, then whoops. It's kind of weird how they want you to do this. I mean, I think it's because we don't know where this... This block should belong to this if. Because otherwise there should have been a block here. But why would you need a semicolon? Okay, I'm not gonna think about it. Okay, so let's see. So if this is true, that means we're at the start of an interpolation. So I will advance. Oh, we could do how they do it here actually. So we'll do this. We get this one or we can check if we're at the end. We will break. Otherwise, we check if we're advancing, or we advance, and then if P is this. Maybe the other way was better. Now we know that we have the thing. So otherwise we will just continue here. Oh, excuse me. Yeah, man. But this doesn't have it. This doesn't have like different things based on what type it is. It just has this and that. So whatever, we can't actually encode tokens within another token. It doesn't work. How should we do this? I was thinking like, okay, maybe we could put the Elixir in a different mode. Like keep track of how much nesting's going on currently in this interpolation part. Or we could change the tokens to actually be able to support that. I mean, what you could do is you could change so that the tag is a union enum, and if we have somewhere an interpolation start or something, or I mean, man, if we could just solve this here as a token string instead. The only problem I see is like the end of a quote, double quote. I guess another thing we could do is, if we encounter this, now we're tokenizing everything here as a new source, but at the end it's going to be put in as a string, just so we can skip past all that, get to the end, and then get to the next double quote. But we're not interpreting these as tokens, but we have to put them, so then this entire thing will be one string literal, and then when we actually parse it, we have to look for these, and we have to then run a tokenizer again in this one, or yeah, we have to do the whole pipeline again in here. That just seems so bad though. I'm thinking about like putting an optional here. It's not really safe, but whatever. I'm just gonna put the, instead of doing, I don't want to make this into a union enum because it fits too good right now. So I'm just gonna do what would this be, like inner? We don't even know. Yeah, because then we need basically to create the segments right here instead in the tokenizer. So this whole thing becomes like a string literal as a segments. This is the first segment. We have this now, a second segment, and then last empty segment here. Or just two segments. And then the segments will be, I mean, lists of tokens interspersed with strings, or I mean the other way around. Man, why can't I think of a more easier way to do this? It just feels like there should be a better way to do it, but maybe it's just a hard problem. I mean, I could ask, okay, let's just ask, no, hang on, tab new. Okay, I'll remove this and everything else here for now. And then I will ask the AI, propose a solution to the following problem. How would we enhance our string literal tokenizer to be able to tokenize any string interpolation expression? The expressions in the interpolations should support any type of unique expression. Please consider, no. Yeah. Should I mention anything else? Do not consider the module parser, only the parser and the flexor. Because it constantly tries to get the module parser into the logic somehow, but I'm saying that part is like deprecated. It's like because the AI, when it first regenerated the code, it like, yeah, it made like different parsers based on different things. So first we had this script, you can run the script file, but then we want to have modules as well. So we wanted to be able to import modules, parse them and everything, and use the functions in those modules. And then it created separate parser for modules only. which didn't use the lexer. It just read the source code right away and basically skipped the tokenizing part, which was very strange. So, and I didn't notice that for a while, so I just, hey, add this feature, add this feature, add this feature, and all of a sudden I had like, the lexer wasn't even used. It put everything into this module parser, and so that's why some stuff is here. That's why I told it now to not consider the module parser and just focus on the parser and the lexer. Yeah, but let's see if we can think about this ourselves as well. Is there any other solutions to this problem? But if we could consider this a starting point and this an end quote, single like double quote, but that's so hard because we basically need to know if we have a start. Maybe that's the solution, like we mark that we actually have a start somewhere, and if we encounter a double quote in a certain state, we know that we're at the end. Maybe we could do something like that, and then we have the start. If we encounter any interpolations along the way, we will have to change, we will have to tokenize that expression until we reach this. This would also become like this is start of expression. Let's tokenize an expression. If we encounter this, that means we're at the end of the expression. And then if we counter this, we're at the end of the string. But we have to know which. So now we're start of the string. Now we're in an expression. But we could get a start of a string again. So it has to be like a nested structure as well. Or like an array or something. I don't know. A nested structure is probably better because then you can, it's less complicated. But yes, maybe. The only problem I see is like, okay, how do we know when the expression ends? Because well, a right bracket is probably good enough. Yeah, that could actually be a solution, because then we don't have to but then, okay, so how would we store that then? But that, okay, so then we actually we could have this. We could have start of string. We could have two different string literals then. We could just have a string literal without interpolation and string literals with interpolations. How would the interpolation start? Well, okay, but then, okay, so I think instead of breaking the things into, we can't have this whole thing as a token. So we have this as one token, this as one token, and then this would be a whole bunch of tokens. This is one token and this is one token, and then the parser have to have like mimic the same logic as well. Hello Vincent, how are we doing? Welcome. Maybe have string literal with start, content, end, I guess. Yeah, that's what I'm thinking. But the problem is, let's say you encounter a double quote, and you say that, okay, this is the start of a string. However, this double quote is not the start of a string. And the problem is you might have double quotes in this expression somewhere. It's going to be perfectly legal to have something like this, you know? Because this is like a separate expression. So when you get in here, this is an entirely new expression in here. You're not... Yeah, so... so that's why I'm thinking that we enter different modes. So if you have you encounter first you're at 0 mode, whatever. Then you encounter the double quote. Now you're in a string mode. Then you encounter an interpolation. Now you're in the interpolation mode. So you're reading an expression here instead. And then you reach the right bracket. Now we end the interpolation mode. We reach a double quote. Now we end the string mode. But if you, let's say you encounter a quote in here. So let's start again. So we encounter this. Now we're in string mode. We encounter this. Now we're in interpolation mode. Now we're at in expression mode or interpolation mode, whatever. We're reading an expression. Now this is a string, so we're starting a string again. So this means we need a nested structure here. So this will become then a new string start. And then we're reading the string, we get to the end of the string, that string ends. Now this whole, that string ends, that expression ends. Now we're out of the inner context and out of in the base, in the root context, and we read this double quote. And in this context we're in the string, so this double quote will now become the end of the string. I'm not sure how clear that was, but that's my idea. That's my best idea so far, I think. Okay, let's see what the AI has cooked up for us here. Oh wow, there's a lot of explanation here. String interpolation plan. Let's take this, move it to, so we don't lose it, into like some document here. I'm gonna do this. Oops. All right. Yes. Update Lexers and next checks for an active string context. Haha! See? The AI the AI is on my side here. Maybe. We'll see. Enter the context when seeing a double quote. Emit the string start. Oh, it basically just says whatever I made up there. This was my last idea. That's pretty cool, actually. I mean that the AI is thinking that this is a good approach here. I mean, does that mean it's a good approach though? I don't know. Emit a string start, a scan forward until next, watching for. We could even keep these as a stack, I think. So we could have like a stack where you push string start, because it should always match up. I think you push the string start, you pop. Or you could have a string, a string start or whatever, and then this one you should push a string or a string interpolation start, yeah. But let's see, that flush the preceding slice as string text and emit. Okay, so they actually want me to create a token. Well, yeah, that's what I was thinking as well. I create a token for a string. The whole string segment, I think. No, not the whole string. Yeah, each segment will become its own token. So string start, string text. So that will become text, but it's basically the whole token will be like a string start token. And then we also have like interpolation tokens. String start interpolation. Mark emit this. Do we actually emit a string start as a token though? I guess it doesn't really matter that much. I think when they say like emit, they mean create a token for string start and string text. Okay, that makes sense. String interpolation start, yes. And then normal token machine, yes. This was exactly what I was thinking. Hey Blue, how's it going? Did you change your name? Is this a tokenizer? Yes. I asked. We have like a. We had a. I asked AI to solve. Okay. Here. Okay. So basically, you want to parse this or tokenize this with string interpolation, and it's not trivial. Because at least to me. So basically you have a string with interpolation, and so the interpolation means here that you are gonna have any type of expression in here. I guess an easier way to do it is probably have something like, you know, printf. I mean, echo, it is supposed to be, you know, you're supposed to be able to, kind of like bash, you know, we're calling echo with this argument here, and you can interpolate. But maybe instead of this, what you could have also is something like, I don't know, this, and then you have like these markers instead. But then it's like a function, and then here you would provide the expressions. This would be way easier to parse, because then you just have this as like a special function. You have like a normal function call. This is just a string. You don't have any special parsing for the string interpolation here. You just have an expression, and the expression is in here. The only, I guess, downside would be for the actual user is maybe arguably harder to use, but it's gonna be way easier to parse. What's the plan? Tokenizer, parser, AST, virtual machine. No, they changed my user. Okay. Yeah. So the thing right now, I think if I do this, I can actually run this right now, but you can, as you can see here, the hello, you know, it doesn't parse this as an interpolation yet. So the idea is that, well, right now we do have like tokenizing and parsing and executing is what we have. So tokenizer creates tokens, parser creates an AST, and the AST can be executed by the executor. Not really a virtual machine. It doesn't really compile to like some sort of byte code or anything like that. We're basically just interpreting the AST and just running it with a Zig program. So yeah, we're basically, you could say that we're running the AST as a virtual machine. Maybe you could say that, because really it's just, you know, it is kind of like, but it doesn't compile to some kind of byte code or intermediate language or anything like that. It's just an AST. I mean, it's all bits in the end anyway. Anyway, so let's see. Yeah, so the problem that I had was how to actually tokenize this, how to parse it, how to make it into an AST, and I went through a whole bunch of different ideas, but none of them seemed, you know, satisfying. So I asked just AI, okay, how would you suggest a solution to this problem? And then during that, I figured out some more stuff, and I came up with a solution where if you have a context currently in mind, so basically you start out with zero context, and when you see a double quote, now you add a context. You have a start of a string as a context. So when you're in that context, you read everything as a string, but then you encounter an interpolation. So now you have to push another thing to the context, like an interpolation start to the context or whatever. And now we know that, okay, now we just need to read this as a normal expression. And then when we reach the end, like this right bracket here, curly bracket, so then we know that we're at the end of that expression. So we push that, or we pop that state, that context. Now we're in the normal string context again, and we reach a double quote. Now we know that we're at the end of the string, and so all of these will become different tokens. So this, I guess, this will be like a string start token. This will become like string text token. This will be like interpolation start token. And then in here is like, you know, normal tokens, whatever expressions are in here right now is just an identifier. And then this will be, you know, the end of the interpolation. Or, well, this is just a right bracket, I guess. We could also have like a special token for interpolation end. I think it's maybe better. And then we have end of a string as well, token. So that will enable us to have strings in here as well, like recursive things in here. Because if you start here, you have the context will keep track of where you are. So you have a string start. If you're in a string start and you encounter a double quote, that's the end of the string, right? But if you encounter an interpolation, now you're in expression mode. So then we are in here, and if we encounter a double quote here, that doesn't mean we're at the end of a string, it means that we're at the start of a new string. And then we reach the end of this string, we know that we're at the end of the string, we pop that context off. Now we're in the expression mode again, we reach a right bracket, curly brackets. Now we know that we are at the end of the only problem here now though, well, I guess it might not be the only problem. One big problem is like when we reach a right brackets here, how would we know to push a string interpolation end token instead of just a right bracket token? So that is the question. Well, let's see what the AI has cooked up here. I would like to guess first. I mean, yeah, because these are the tokenizer doesn't really have a concept of these expressions in here. It just knows how to tokenize in that mode. So we're in expression tokenizer mode. But if we reach a right bracket, curly brackets, that means that we should just produce a right brace. I guess it does have it does talk about it here, or braces, whatever. And then the end of that. I don't know. Let's see what the AI says here, and let's see if it makes sense. So it says here that we are first we encounter this. Then we have a string start token. We either encounter another double thing, which means we should have a normal string, or we encounter this, which means now we should emit a string text until that. So that will be this part. This will become one token. So this is string start token, this is a string text token, and then this would be a interpolation start token. Let the normal token machinery run for the embedded expression. Track depth. Oh, I see. They want to track the depth. So this will become a little bit more. Yeah, we have to do some more logic with these things here. That's the. I guess, yeah. I guess we can't get away with it. So a right bracket only closes the interpolation whenever counter is 0, otherwise they emit the ordinary or brace. Like this could become complicated if we implement other things that could, you know, affect this. So I don't really like it, but I'm not sure what else we could do right now. because the tokenizer doesn't really have a concept of what kind of expression makes sense. It just parses the tokens. So yeah, it has to know when this makes sense to have the end of the interpolation. That logic it has to know. So that's what this is about here. Only closes the interpolation when every counter is 0, otherwise emit ordinary or brace when the interpolation ending is found, emit a string interpolation and constant, and resume text scanning aside. When the closing clause is reached, flush the returning text. Yeah, so when we reach this, we pop the interpolation context, we're back to the string context, and so yeah, and then we continue as normal. So then if we can implement all this, this should be fine. Oops. So then resume text scanning and another string when the closing is first. Yeah, that's it, just same thing there. Emit string and yeah, and pop the string context. Yes, this gives the parser ordinary tokens for a better expression by guarding parameter. Yeah. Needs to switch from slicing to consuming string tokens. Yeah. So this is just adapting the parser to actually be able to read this. Now, what would that entail though? Like, it should also have the context, but that the context with the parser is more like having a I think it's gonna be more like just the structure of the calls themselves. That's kind of the context that we could keep. So when you encounter a string start, now we're calling parse string segments or something, and so you would encounter either a string text, and that would become a text part. You would encounter an interpolation, that would become an interpolation part, and then you just have a nested parse, I guess, interpolation expression, because you want to parse an expression and then also parse the end of the, well, I guess this would become, you could parse, yeah, the start of the interpolation, an expression, and then the end of the thing. And then yeah, so that's not too bad. Okay, so what's this? Any parser routine currently treats stage terminators. Yeah, must add string interp end to their stop set. So yeah. Update the lecture unit tests to cover cases like This change confines it. You could do that. You could deal with the unit tests, Mr. AI, or I don't know. This change confines all work to the next parser reducer. Yeah. Okay, so yeah, so that was basically what I was thinking. So so yeah, we don't do things here. What we do is we go to literal. Wait, where's the elixir? Yeah. So okay, let's remove this part. I'm just gonna grab a glass of water. I'll be right back. Hello, Exodus. What's up? Yeah, thanks. I will keep up the progress. Are you a developer as well? Let's see. So, all right. Now to implement this. Let's see. So we're in the leg string. We should begin by adding the context stuff. So we should have. I was thinking like a stack. Do we need to know where the things are? Let's just add like a context stack, I guess. Context stack. I don't. By the way, I don't like this. I never use kebab or wait, no, it's not kebab case. It's snake case. But I guess it's kind of convention, so whatever. I usually always use not Pascal, camel case, or Pascal case, depending on if it's a type or whatever. But yeah. Anyway, it doesn't matter that much. Context stack. So we would have like a stack. Well, it's basically just gonna be an array list of contexts, and we're gonna set it to empty. Actually, I'll just call you context and create you over here. No, so you will be like a union enum probably. So we could be at a we could be in a string, or we could be in an interpolation. String interpolation. Those are the two things. What's this language built on? Is it interpolator or encoder? I'm building it in Zig. And the thing I'm building right now, this is the Lexer. And I'm trying to build this. I'm trying to build the functionality to be able to tokenize this into a meaningful thing. So I can pick out the expression and properly parse it into an AST. So right now I'm trying to upgrade the Lexer to be able to interpolate this, to be able to parse this correctly here. So let's see. So we have a context stack. The context, so either we're a string or a string. Now we probably want to keep track of where the string started, maybe, or the current, like, because we need to, if we encounter an interpolation marker, like let's say we start here, now we're in a string context, right? Then we encounter this. So either we're encountering another double quote or a dollar, string interpolation start. If we encounter a double quote, that means the string ends. So that means that we have to go back here and grab all the things after the first double quote. Or actually we could, no, we don't include the double quote. We just take everything in here and put it as a token, as a string token, string part token or string text token or whatever. And then that would be the end of that string. But if we encounter an interpolation, we want to push interpolation stack, interpolation context on the stack, context stack, and now we're in expression mode. And we get to the end of this one. We wanna, we pop the interpolation context. Now we're in a normal string context, and so on. So, so that's the idea here. So we have the context stack. Let's make a function to get the current context, and this would return a context, and we'll just return, I guess it would be like a nullable context, or we could start automatically with one with like root or something, so we always know we have one. So this one, is there a way to get last? Yes. So we just get the last one. When we initialize, we could init from a buffer. Now I'm not sure if this buffer, I don't think this works with read-only slices, so yeah, I think we have to do this, so we have to say like or maybe we could just do this, don't have this, get last or null, or else actually we do have a root, or else we return a root. There we go. So if we don't have any items, we're at the root node. Otherwise we have, okay, there we go. And then we have like push context. I guess it's an errorable. This would be like append. Oh, wait. Oh, we need an allocator. We actually don't use allocators here. Okay, well, let's just add an allocator, I guess. We could also make like an arena. That'd probably make a lot of sense. Arena. Tokenizer breaks expression into small pieces, recognizes a string. Yeah, no, it's fine. I can explain. So the tokenizer, I mean, okay, so basically the tokenizer, all it's doing is basically is just loops through the string. So everything here at the start, you know, you're reading the entire file as a string. So you have this as a string. And then the tokenizer goes through each character by character. And then depending on kind of the context of what you're doing, you're going to interpret the character differently. So, but from the start, now we're encountering a alphabetic character here. So presumably we're at the start of an identifier token. So you're basically dividing the source into tokens. So this will become an identifier token. It's gonna read this all these as alphabetic until it reaches like a white space, and then it's like, oh, so you have an identifier here. Okay, there we go. Here you go. This is a token. It's an identifier. Then this white space, we basically skip this white space, and then we're over here. So now we're trying to read a string. Yeah, that's what the tokenizer is doing here. And then so it's basically just, you don't really have to have a tokenizer, to be honest, to be able to parse and execute a script code language, but it's nice as a step in the process to reason about what kind of how the language is structured. So usually you have this tokenizer to get the tokens, and then you can reason about what tokens are we getting and how should they work together. So basically here we have like, okay, we start with an identifier token. Now the parser is coming in. It takes the tokens, So it's like, okay, first we have an identifier token. Okay, so we should have like the start of a command here. And then it's reading, okay, so then we encounter a string token. And, okay, so that's the argument to the command. And then we end. So now we know that this whole thing becomes in the AST, becomes a call to this command with this as an argument. So it's like, we're doing it in like stages. First you have the source. The source, you run it through the lexer to get tokens, or the lexer / tokenizer, and then you run that through the parser to get the AST, which is an abstract syntax tree, which is just, you know, another representation of how the code is built up. And then to be able to more easily run this, and then what we do here is we run it through an executor, which will actually run the script. So that's what's happening. So right now I'm in this part trying to add support for being able to have this kind of expression where you have a string and you want to put some kind of value into the string here. And it's yeah, it's a bit tricky. So yeah, let's see. Oh yeah, so I needed an allocator here. So we have an arena in it. We also need to add a deinitialize function. Basically just call arena deinitialize. There we go. You don't actually need to be mutable, so let's do that. So we will need to call this to clean this up, and now we can actually get our allocator, which will return an allocator. We'll return self arena allocator. We also need self. Now, do you need to be? Yes, you need to be mutable. Okay. Okay. So let me move you down here. There we go. So you have a sort of have a chain of logic and you're working on a tokenizer. Yeah. That is correct. All right, so the allocator will enable us to allocate memory if we need it. And we do need it if we have this stack here. We need to use the allocator. And here we actually need to pass in an allocator, which will serve as the base allocator. And we can say arena is going to be a new arena with this allocator as a child. Yes. Okay. And here we will just do this now, and this is the item, and we'll do a try there. Functions, shadows, what? Oh, wait. Oh, yeah, so I'll just do this. Here. All right. And now you need to provide an allocator. And you wait. Stream. yeah, we have a elixir and then a stream elixir, or yeah, as well. So this one we will call self elixir initialize. There we go. Okay. Now back to okay, I'll fix that later. Let's focus on this one first. So let's go back to where we were here. Where were we? Here? Yes. Push context. We also want to pop context, but we don't care about the return value. So I will pop. And I guess technically it could be, if this is null, this should be an error. So I'm gonna say or else context stack error or something. I don't know. Context stack pop. How would that? What would that be called? Context. Context stack overflow, underflow. I'm gonna call it underflow. I don't know. Or else return error context stack overflow. Okay. We don't have this, but we do have that. Yes. And we don't need to bind you to anything. There we go. All right. Now we have the context. Now we also need, the thing now is for each context, we do need some stuff. So the interpolation does need to know, we need like 3 counters. So we need like parent counter, so parentheses counter. We need bracket counter or whatever, and brace counter. Yeah, and yeah, so that was just what AI came up with. We need to keep track of these counters so that we know that if we encounter a right brace, that means that we should end the interpolation, but only if all of these are 0. So I will add a function to say that can or something. I have to sleep school to 3 AM for me, but I have subscribed. Ah, thank you. Yeah. Have a good sleep. See you later. All right, so I'll just have a function here like should end or can end interp or something like that, or can end, I guess. Bool, and we just return so this should all be 0. All right. I wonder what's faster, if you do like bitwise and or add, because they should be, it should both be correct in this case. No, not and, or bitwise or. that should both be correct at this point, because it might even be also safer, because you can't overflow. I mean, you could do this. No, not this. This to guard against overflow. But I think this actually might be faster. I don't know. Maybe not actually, but whatever. We're not gonna get up to those counters anyway, so I'm just gonna do this maybe. No, let's do that to be a little bit edgy. Okay. Explicitly valid. What? Oh. No, it's a type. Okay. Hello, Nab Gaming. What language do you use to make the language? This is Zig. Here you can see .zig. That's the language. Really cool language, and I've been. It's a kind of a new language. It's been around since I think it was like 2016 or something like that. Somewhere along there, but it's still it's taking its baby steps. It feels like still got a ways to go before it's like has a official sort of first version release. Right now it's version 0.15.1. Why use Zig and not a language like C++? Well, I wanted to learn a new language when I started with Zig, and like Zig is turned out to be one of my favorite languages right now. Possibly my favorite language, actually. Because I don't know, there's something with it that it just feels so nice to use, and it just feels like you can do so much stuff that you can't really do in other languages as well. But yeah, it's a low-level manual memory managed language, and it's a bit different, like you know, in philosophy than C++. It doesn't have a lot of features that C++ has. But it has enough to be able to do stuff. So, but yeah, I guess it tries to be a little bit more focused in its design. Is this NVim, NeoVim? What's the window on the right? So this is NeoVim, yes. This is also, you know, this is just another buffer in NeoVim or Vim, which I opened. This this is the script language that I'm using here. This is Runic. It's called. This is the file name here. It's actually super cool. You need the power to make an entire language super hard for fun. Yeah, it is fun. I love programming and languages, and it's just, this is just pure programming joy to make a language. So it's really fun. Thank you for being here. All right, so let's see. We have this context here. Okay, so are you, by the way, are you Nab Gaming a C++? Do you know C++, or are you a C++ developer? So yeah, let's see. So we have the context here. We have to keep track of the counters. And I wonder how the lex string, how that worked with. Oh, I see. We have like marks. Start is the mark. Okay, so we're kind of doing that first, and then okay. I was thinking like how it knows where the string started once we've advanced. So that's how we're doing it. Okay, but now we need a little bit more advanced things. So we have the context where we do all this crap. The string could probably be just marked with the start. Well, we don't really need that, I don't think. Root. Okay, that doesn't need anything. Okay, I think this is all we need. So let's see if we can now implement this here. So if we encounter a double string, we should really have a separate function, because we could be okay. Let's see. Nav gaming. That sounds so much like an AI writing, to be honest. But sorry. I've used Pygame once for like a long time ago, so I'm not sure if I can make a course. But there's probably a lot of courses, available for Pygame. So you could look at those. There's like, it has existed for a long time, and I know for a fact that there are a lot of them. So just search for it. But you could look at, if you want to use Zig, you could look at some of my stuff if you want. But I don't really have like a tutorial or anything like that. I just show like the game development, but yeah, I don't have much, I'm just showing like I have a game that I'm developing, and I'm showing basically the development of that in Zig and Raylib. Okay, learning computer learning C++ right now. I know a bit of C. Okay, cool. You're a web dev channel doing all sorts of things outside of that. Yes, so I'm a professional web developer for 10 years, and before that I also, I've been self-taught in programming for a long time, and but I haven't made a bunch of projects or anything like that. I just learned programming because I wanted to make games first, so I learned C++ first, and then I realized that, wow, I really love programming, so I just learned a whole bunch of different languages and paradigms and stuff. But yeah, now Zig is really cool language. Can Zig make games? Yes. Zig actually, so basically Zig, one thing to realize, that Zig can do anything that C can do, and more, I would say. I mean, okay, I would say some things are easier to do in Zig, I would say, like that. And then but yeah, and C has, Raylib. You could use Raylib for as a game, library for rendering, playing music and stuff, and that actually has like Zig bindings. But you can also just import any C library into Zig, and it has auto completion, type. It converts the types to Zig types and everything, so you can just import a C file, a C library, and it just works, which is incredibly cool, into Zig. So yeah, it's a really cool language. I mean, there's other languages that can do that as well. Basically, anything. It started out using the same backend as Rust and a lot of other. I think Odin as well, like LLVM, is the backend, and so. But now they've started to move away from that because LLVM has a really slow like compiler. Apparently, so they are making their own backend for compiling the code, and so yeah, I don't really know all the things about it, but yeah, that was what enabled it to actually interface with C as well, because LLVM kind of had that like built in almost. But yeah, that's one of the main selling points of Zig as well, in order for it to eventually maybe replace C as the low-level kind of simple, I guess, low-level language, because it could you could replace parts of the C infrastructure or whatever, the C ecosystem, with Zig, and still have it work and interface and everything. That is at least a potential of what you could do. Crazy how you can program a programming language. I always thought they were written with themselves. At least that's the impression I got. Yeah, so, well, you start out by writing it in another language. And then usually it's like kind of a thing where programming languages oftentimes rewrite themselves into their own language when they can. And then... But this is not really going to be that kind of language. This is more like a scripting language. So this is more like a bash script language, you could say. Like this calls the echo executable with this argument. But then the plan is to have all sorts of nice things that will look more like a real program language instead of this weird bash syntax that I don't like. Like bash is great and bash does things very nice, but I don't know, I just wanted to make something that I could use personally instead of bash, because I've been using it more and more lately, and every time I need to look up every time how to check if a file exists, or how to check if a directory exists, or do a loop with this thing, or like everything has a special syntax and special kind of thing. So I'm just you know, I just wanted to do this because I love making languages, and I love to make tools, and so this was kind of the start of that. So it's really just a toy language for myself in order to avoid using bash. All right. Have you seen Bun Shell? No. I also, that's another thing. I haven't actually looked up any alternatives to bash, so you can bash me on that. But I just wanted to make a language, okay? And also, I should say also, like I also, this was an experiment with AI tools as well. So this was started out using AI. So AI is basically all of this is AI code, everything here and everything else basically. So but now I realized the AI was doing some weird stuff in the code, and it went in a totally different direction. So I need to go in and reel it back in order for it to also my AI power ran out, so I have to like do stuff manually here. But I was actually surprised how good it could do Zig. It was interesting because Zig is not that popular of a language, so there's not that super much, you know, to learn from, I guess, projects written in Zig. but it does use like an old syntax, or well, not syntax, but old library, because the standard library changes a lot right now with the current versions and stuff. So it was using like an old thing, but like an old version of Zig. So I had to like manually patch it and stuff, but it does a pretty good job actually a lot of the time. But it did went a different direction that I wanted to go. So I'm trying to now more manually do the stuff. Yes. Okay, so bash shell, mostly bash JS interpolation. Yeah, I was thinking also like, because the thing is, I want to have like a zig-like syntax. So basically, you're gonna be able to say something like whatever, or let's do like result is a struct, and it has a payload or something, and then a okay. So basically something like this, and this is very zig-like, except we don't have semicolons. So this is very zig-like here, and then you would have like, you know, if result okay. You could also have like, let's say you have another result is gonna be like this. Okay, so then you would get the result out like this. So basically, it's basically going to be a zig-like scripting language. A scripting language with zig syntax is the idea. So that's pretty cool. I just love the feeling also that you can basically just make whatever you feel like, and you know, like you have an idea, okay, let's just make it. The only thing that's in the way is like time and effort, you know. And that's not to say that's not anything, because that's a lot as well. But I just enjoy it. I just make it because I enjoy it. AI is impressive use of anything more than one of script files, because they think, yeah. You can also use it. So I basically here I asked it to solve this string interpolation issue. So, and it did a pretty good job actually. It came up with a solution that I did have in mind, but it also gave me some tips on actually how to implement it correctly. So I think it has been, you know, pretty good to use. But I wouldn't, you know, you can't just tell it to make this project and it will go ahead and just magically create the whole thing, depending on, you know, how large it is. But you can ask it to, hey, make a plan, make a step-by-step guide. So that's usually how I do it now. I'll tell it to, hey, I want to do this. Make a step-by-step plan to actually implement it. And then I ask it to basically do the tasks themselves, like do the task number 1, do task number 2, blah blah blah. You can even tell it to keep the progress in a progress file, and then you can just tell it, hey, do the next task, and it will update the progress as it goes along. The only thing you just need to make sure that the actual plan is what you want. So you can't just, because oftentimes it does things that you don't want. So you have to sort of reel it in, or be more explicit in your requests. So, and it has been pretty good at implementing stuff. I mean, I am super surprised. It has improved a lot in recent times. So I remember using it to implement stuff before, and like a couple of years ago or something, and it was like horrible. But now it's gotten so good at doing the thing. So, and if you wanna, I guess if you don't mind living with a little bit of AI slop or whatever, then it's you can be incredibly productive with it. Okay, but let's see if we can focus here. Let's see. let's see. So we start a string, right? And we get a double quote. That means we're ending. Okay. I guess we bring this back here. Let's get the next one. If this is a $sign, and if we're at the end, we will break, I guess. No, wait. This is wrong. We need to, so what we need to do is we need to push a context here, a string context, and then we need a separate function. No, we don't need a separate. Like, do we, like, how we do this? Did it like recursively recall this? I guess probably. All right, have a good one. Thanks for joining. Yeah, good luck in becoming a software engineer. It's really fun. All right. Let's see. I want to be a full stack developer, but use state is so hard to understand. So you're a backend developer, I guess. So, okay. I could try and explain it, but it's, I mean, I think what you're having trouble with is probably, I'm just guessing because I don't know anything else there, but I think you probably have trouble with the whole paradigm itself. If you don't understand use state, you should understand how like the React sort of works first, because then use state is pretty trivial to understand. It's just a state that you can manually update with the function that you get. So yeah, I would consider just reading up a bit on how the React sort of engine works. You don't have to know the entire engine. You just need to know the kind of the idea, like the theory of it, like and just start with an extremely simple example. Like you just have a component that is being rendered, the only component being rendered. React basically just renders it. It's like a game loop almost. It's like a loop structure. You have a loop, but you don't need to run the next iteration if there hasn't been any updates. And it basically just keeps track of when you call basically set state, it will run another loop that will just render everything with this new state. I guess that would help if you're familiar with like game programming, like game loops. Let's do try. Okay, we need to expand this error to also have allocator error, because now we're trying to use allocators as well. All right, so we're pushing the context. We are advancing. If we encounter this, we should pop the context It's not a try. Pop context. Actually, is it a try? Yes, it is a try. Oh, I see. That's not a try. There we go. So we push the context string. If we encounter that we are popping the context, we should also push a or emit or whatever it's called. What is it called here? Next? No. How do we make a finish? Oh, that takes like the mark into account, I think. Okay, yeah, we need more tokens actually. String literal is not the only thing we need. Let's make a new thing here called string tokens. So we have like string start, string end, string interp start. Come on. String interp end, and string text, I think it wanted us to call it, which is fine. And so string literal is no longer a thing. So I'm gonna delete that. And now we get a whole bunch of errors in the tests because we have a bunch of tests. So I need to tell AI to update the tests. That is one thing that I think is nice. The tests. You can automate the test writing with AI. Actually, Nav Gaming, you can actually you can ask, go to ChatGPT and just ask it to explain that, because that's so nice. What's so nice about AI is that you could contra Googling and trying to find articles, trying to find specific information. AI can just answer any question you have, and granted, it's not always accurate, but I think it will be pretty helpful in this case. Because it might not be it might not be so easy to explain just in a couple of sentences. Even though I could just say that I could just say that, yeah, it's a loop. It just renders when there's an update. If you call set state, it will render again with the new state. I say maybe reasonable to understand React because I'm stacking languages on myself and just 12. Oh. And already stacking on myself. Python, JS, React, and Python. Oh, okay. Well, yeah. I mean, yeah. You should focus on maybe one thing. I guess it's easy, like when you're new and trying to learn programming, since it's so much to learn. If you're learning multiple at the same time, it's easy to like crisscross the wires in your brain to sort of think about I don't know, it just seems more you probably want to just try and focus on one thing. I think that sounds reasonable. I'm gonna do finish string text. However, we don't want to include this thing. So I think what we want to do is we want to peek instead. And why are we like forcing an unwrap here? That's kind of weird. Okay, whatever. So we're peeking. That means when we finish, we should mark after the advance. Yeah. So now we get the inner part of the string instead of like the outer part. Like with the double quotes. Without the double quotes we're getting now. Each time I write JS code, I would print, and each time I write Python code, console log. Yeah. Yeah. I mean, that's one thing. It's also maybe like mixing the concepts, and I don't know. it just feels like it makes more sense to focus on one thing, and then when you've learned that a little bit, like landed a bit in the language, then go out to other languages. But that's how I did it. But I don't know, that it might work also. But if you feel like it's confusing, you should probably just stick to one language. It also makes sense what you're saying, like you want to make games, I guess, so you're learning Python and Pygame, which makes sense. It's an easy language to learn, in my opinion, because you don't have to deal with a whole bunch of stuff with statically typed languages and stuff, and you can just write the code directly and it just runs and stuff. But JS and React does also make sense in a way if you want to get a job with web development in the future, or just making websites, I guess, as well. But you don't really need JS and React for that. You can just write HTML directly. It makes sense to learn, HTML, CSS, JavaScript before you learn React. I don't know how that... Actually, I don't know how they do it nowadays, actually, if they start with... You have to start with HTML, because everything is built on that. You don't start with React. I don't know. Is it compiled or interpreted? It's compiled. It is a compiled... It compiles to native machine code. Just like C or C++ or... Yeah. I was gonna say like C#, but I don't think... Does that really compile to... I think they have like some kind of intermediate... whatever. Yeah, C or C++ anyway. Okay. Okay, so let's see. So we mark here. We have now, that should be the inner part. Yes. We're looking for this. Then we have ended the string. Actually, this doesn't really work. We need to separate these things. Yeah. I think what we need to do is we need to say, yes, that is the start, but we need to push the context, advance, start, and then we just end. What happens when we end? Next, I think they just call next somewhere. Yeah. No? Yeah, that should be good. So we just call that and we end the function. Then we have a separate function where we have string text, I think. All right. Now here we do this. So we say, no, but actually we could mark, we could do this maybe. I don't know, it doesn't really matter that much. I was thinking maybe putting an advance in here as well, because we're gonna advance whatever we are gonna have, but whatever. Okay, so here now we're looping and we're looking for an end quote, then we pop context, we finish with the peak. We should also, so this would be the token. and then we should do next, but we just throw it away, so we consume that last thing, because here we're just peeking. That means that we don't consume the next tokens or the next character. The index is still the same, and then here we actually we need to consume it for the next part. We can have these things, we can have, so here we need to check for interpolation start. So let's do, oh, you already learned fundamentals of HTML, some CSS. Oh, nice. Syntax looks like hell. I mean, I think it's okay. So one thing that I don't like, but it is easy to get there in Zig, is nesting. You get a lot of nesting because of how the things work. Oftentimes you are in a struct like this. I'm in a struct. This is like an inner struct as well. There's two indentations here, and then you have these loops or something else. You have an if. If you want to make this into a function, that's also a little bit annoying, because then you have to send in everything you need in the context. Maybe that it's not that much here actually. It's probably not anything, but you could technically put this in a separate function that will reduce the nesting a little bit. Yeah, and then, but most of this syntax is like basically it's kind of C-like right now, the syntax here. I'm not sure which part of the syntax are you referring to, and also maybe you're using a little bit of different constructs here than you're probably doing in other languages. Like in modern JavaScript, you would probably use like a map or something else. But this is also, you know, you're looping through something that you don't know where it ends, so it makes sense to have this while loop here. All right, but anyway, I'm gonna get the possible start here, so I'm not sure why I'm calling it P, but whatever. And this would be, so basically, no, this is not next, this is advance. Next we'll read a whole token. We're peeking there. So I think if we don't have a quote, we should just advance. Actually, no. So here we do an advance. And then I want to peek on the next one. I guess I call it P because it's a peak. Yeah. Wait, peak is just a nullable. Okay, so it's not try. There we go. If okay, so let's do this. If we have this, we also want to check if it's a this. So now we know this is gonna be a why am I the one watching? I mean, I think it's a rather like niche thing. I think there's a lot of people actually trying to make languages. It's just that if you haven't looked for it, you don't really, you know, how would you notice it? I appreciate you being here though. And I like talking about programming, so it's nice to have people around talk about it. But yeah, there's a lot of languages, you know, being, especially now when it's more easy than ever to actually do it, because of how many resources online you have at your disposal to use it, like AI tools right now. You've got, you know, if you want to make an actual real programming languages like Rust or whatever, you can use LLVM as a backend, and you get like, I don't know, 80% there or something with that, or 50% at least. I mean, there's so many tools and stuff out there right now to actually try to make your own language. And I mean, there has always been tools, actually, to be honest, but now, of course, that's gonna always be the case. Like, whatever present moment you're in, that's probably gonna be the best time to. I'm just saying, like, lately there's a lot of nice things for making languages, but it isn't easy, because you have to make up the rules yourself. You have to learn a whole bunch of stuff, how it works, but the principle is pretty simple, and kind of depends on what kind of language you want to make as well. So this is going to be a pretty simple language, but this is probably the most advanced thing that I have right now. Like this string interpolation, it was way more advanced than I was thinking, but once it's done, we'll see how really advanced it is. Okay, so anyway, so we have this one. We're advanced to consume this. We're picking to see if this is it, because if it's not, then we just want to continue. We could get away with not picking, I guess. We could do that. Advance, and then just do a next, or not next, advance. Is this a try? No, it's not. Okay. So if we have P, or I mean, let's see, maybe interp start. Then actually you could just do this. Actually, you could just do that, I believe. Even though it's a, it's an optional, you could do this. I'm pretty sure you can do this. Yeah. So then, also what's really cool is that I'm also using LSP, or I mean, I've used AI to produce the highlighting of this in NeoVim, but also I want to also have a little bit of LSP stuff, which means basically you get things like diagnostics, auto-completion, just those nice things that is kind of taken for granted right now with new languages, which I think is really cool. So, and AI really helps with building the foundations for that, and then you can just expand on that. Okay. What is happening here? Oh yeah. So we return this token here. There we go. Oops. Oh, I see. So this would be string text token. What is your issue? Oh, probably something returning something. Okay, so if we have a start, what do we do then? We want to push an interpolation context, interp, and I'm just gonna say empty, and probably just gonna make this here. No, actually, it's just gonna be this, because they all have default values. So now instead of doing this, you can just say .interp. A lot nicer there. Okay. Yes. That's also really cool. I just love this. This is one of the coolest things about Zig. And I haven't seen it in a lot of other languages. I'm not sure if I've ever seen this. It's basically just, you can type dot, and if you know the type that you're supposed to have here, then it will actually like autocomplete or be able to understand, okay, well, you want to have some function from this here, a static function that returns itself, basically. And so you can just say .interp and it will know which function to call is calling this function. That is so cool. So that actually, it helps reduce the amount of characters you want to, because otherwise you have to do it like this. But now it's kind of, it just knows that that's the function you want to use. So that is really cool. And it helps a lot, because especially if you import some function that has some type that you don't have in the current scope, but you just call the function and then you can just type dot and it will, you don't have to import the type, you just you can just autocomplete your way there. So that's also really nice. What is happening here? Oh yeah, there we go. Okay. Let's see here. So push context there, and then I think we just break. Maybe we have to break, and then we have to also create a string text as well. No, we return this. There we go. Okay, let's see if this is the correct thing. So the start should be correct. We started there. If we start an interpolation, this is wrong actually. We should finish before this one actually. So let's, man, the mark is only for starting tokens. I wonder if there's a way to do this except with a special, oh, you supply the start. Oh, but we want to supply the end is the problem here. Yeah, we want an end. Finish, mark. I guess we can reuse this thing. I'll make a version of finish, or you could do, let's do like token finish type. And this would be enum union probably, or just a struct where we have the start or marker, token start. I'll rename this to mark actually, token marker. And then the type, which will be an enum, and it's gonna be like, which mark will this be? Will this be start or end? And then we'll make a function called start, which will take a marker, token mark, and return a finish type, and we'll return marker's marker, and type is start, and we'll do the same for end, and yeah, that's it. Whoops, this is not return, this should be pub, there we go. And now here, instead of taking a start, we actually take a finish type. So this is kind of how, because there's no, there are no overloads in Zig. So what you could do is you could make a type that you put in instead that will kind of determine what you want to do. So you have a, we now have this finish type here. There we go. And so if the type is start or end, that will, you know, determine what we want to do. So we'll put this finish type here, and the, let's see, and the start. So this now is the thing. So start is gonna be let's do this. Maybe we'll switch on finish type dot type. If it's start, we will return the start is going to be the marker, and end is going to be self location. If it's end, it's going to be the other way around, like this. By the way, I'm going to stay on the stream all the way until it ends pure respect to me. Language around. No, you don't have to do that, you know, but thank you. I mean, it's nice that you think it's cool with making languages, so hopefully maybe in the future you make your own language. It's, you know, it sounds like you think programming is fun. If you're learning like 3 different languages, I'm impressed, like with actually like 2 different also like libraries and stuff. Okay, so basically what we're doing here is a tuple deconstruction. However, this is a location, this is a marker. Yeah, we have to access location. This needs to be a tuple of the same type. So you make a tuple here of 2 elements. If you deconstruct it like this, you have const start, const end equals something else with a comma. That means the start will become the first element of the tuple, end is the second one. And so now, depending on start or end, this is going to be, you know, you're going to use the finish type on start or on the end. It's kind of a bit confusing now that we're mixing it, but you could also just supply 2 different things. I think this was just convenient in order to not having to type the end specifically there. Oh yeah, this is a span as well, so we could actually we could just make this a span. No, which one is this? Token span, yeah. And that, but now we need to say start and end like this. Or there might be some function. No. From to, yeah. From to. Yeah. There we go. That's a little bit easier. Oops. All right, and that's the span. And then here we can just supply this span here. There we go. Start index f. Okay. Now this is also needs to change. So this should be offset, right? I think. So span start. Actually, the span should have a function. Then it should have like a function called slice from or something, and we have like the source, and we get another slice, and this will just return that. Self index. Yeah, we'll see if the index. I wonder if the index has updated yet. If it's inclusive, that's always the one-off error thing here. Span slice from this. All right. Okay. Now all of these need to update here. So the idea is that you put dot start, and then you just put this marker here, the start marker instead. So I'm gonna replace all of those. Finish. With dot start. Damn. Okay. Hello, Rabbit. How's it going? Is that Vim or NeoVim? This is NeoVim. Almost the same thing. Expected type frontend token span. Oh yeah, so this is wait. Oh, I see. Let's do like from locations. Start offset. Wait. Yeah, that's just the actual thing. Whoops. No, it did this weird thing. Okay, Elixir from locations. There we go. Okay, you're still angry. Yeah, okay. So this would become a string start. Which should exist, no? Where is this? No, wait, I removed that, that's right. Token. Yeah, there's string start here. Why is that not? Oh, that's the tag. Oh. Let me just remove that. Elixir string start. We will return tag is string start. Let's see. Yeah, thank you. Let's see. Thank you, Rabbit. So this one would just be this. This would just be like the start. I mean, we could just do this. Start. Do mark. And then let's finish. And the tag string start. There we go. All right. Yeah, cool. I don't know. Yeah, okay, yeah, that should be fine. Yeah. So we called it, this should reproduce just a string start token, string text. Now we're assuming that we're in the string context right now, and so we are looking for an end of the double quote. If we have this, then we exit the string mode, we produce a string text token. We also advance here. Also finish could actually take 2 as well. What you could do here, you can add another type, but then we have to make this into a union enum. But you can technically have another type, which would be like start and end. But then you need 2 markers, so that's why you need to make this into a union enum instead. Which would sort of handle all the 3 cases. You would have a start, you would have an end, and you can have another which is like start and end, which would make it so that you can supply as a separate what is it, option there for that. Okay. Yes, and all that. That's good. That's good. So now here we might start an interpolation. We get that. We advance the dollar mark. We advance the thing there. Actually, technically, that could be an end. That could be a double quote. So maybe we don't advance. Maybe we just peek, actually. Yeah, we're peeking. We're peeking that. Hello, hello, A6. How's it going? I'm doing good, I'm doing good. Continuing on my little scripting language here. Just want to make this tokenizer work. We can look at then when we've done this tokenizer, we don't have to implement everything to make it work, or to make it work. We could look. What I mean is we could look at the tokens later to see that it's actually correctly tokenizing the things, because there's a tokenizer mode. You can just say, hey, give me all the tokens of the thing, and it would do that for you, so you don't have to implement the whole pipeline of parsing the tokens and then executing the tokens before you can see that it actually works. We can test each part separately, so that's nice. So I'm gonna do that and try to make this tokenizer work for now. We'll see if we get to the AST today, but let's see. Are you working on a game or a language? I'm looking on the language right now. I've been stuck on this a little bit. I just think it's too much fun. I needed a little bit of break, I think. But I do want to get back to the game at some point as well. Let's see. Yeah, the YouTube chat is a little bit laggy. There's a significant longer delay than on the Twitch one, I've noticed. Anyway, so let's see. Maybe right. So we're also making a token here for the string text. However, yeah, so here we do the advance. And we start an interp context. We return the string text token. Yes. And then we're done. Okay. So I think we're done with that part. Now we need to take care of the expression but we need to modify the existing stuff. So here is, this is the next function. So this is the function this is the entry point into, hey, I want the next token. And we wanna check if, yeah, we don't want to do this because we might be in a string right now. And what we do is we do switch on current context. If we are in a string context, we want to return string text. Yeah. We could also be in an interp context. Then we return. Yeah, okay, so actually if we're in any other context, we actually don't do anything here. We just want to check if we're in the string context. So actually we could just do, since we only have one case, we can just do this. There. If we're in a string context, that means we're currently trying to read the string, because the string could be separated because of interpolation into separate tokens. So we're continuing to read the string here. Okay. Now, otherwise, we're just trying to read any kind of expression that we want. However, if we're reading this, we need a special case, because we might end an interpolation here. So let's have an if here, or maybe even up here. If this is that, and current context and then we also switch on the context, and we have an interp context, and if the context can end, then we return, first we do self advance, and then we return finish. Start is well, we mark a start here. Oops. And then we also say tag is string interp end. There we go. Okay, so basically in our normal expression token parsing, if we encounter this could either be, if we're in the normal context, this could be like just a right bracket. But if we are in an interpolation context and we can end the context, that means that all of the counters for brace parents are 0, then we should end the interpolation. We should also pop the context. There we go. Oh, try, wait. Yeah, okay, yeah, we try, pop the context. There we go. And let's see. Are language going to be Turing complete? Yeah, I'm pretty sure it's going to be Turing complete. From what I've gathered, like, Turing completeness is not that hard to accomplish. From what I've seen, I'm not exactly sure about the prerequisites for calling a language Turing complete, but yeah, I'm pretty sure you could do basically anything you want in it, probably. But it's gonna be like a scripting language. So the purpose is not like a general programming language. The purpose is more like making, you know, running commands, like running executables and starting processes and stuff like that, like a bash script, except like a different syntax. That looks more like Zig, because I like Zig, and I'm kind of obsessed with it. Alright, so now that should create an interpolation, and that is good, that is good. Then what? So then we pop the context. Now we should be in a string context after that. That should always be the case. It should always be like either string or interp. If you're interp, you pop, you should get into a string. If you're string and pop, you should either get into an interp or the root context. Anyway, so now I think the only thing missing now for the tokenizer is to keep track of these now. So anytime we open a parent and a parenthesis, we should modify this, and a bracket and a brace. Okay, so that should be here. I'm gonna make a function. Oh, this is a return. Okay. Well, you could do this. You can make a label, and we can do break the label like this. There we go. And now we can have any kind of expressions or statements in here you want. So in case of an open parentheses, we are going to say self. I'm gonna make a convenience function, which is like start parent, and it's gonna be the same for braces. Start brace, and the same for brackets. Also, we should have for end as well, so I'll make that in a second. Start the bracket. We should probably, maybe we should even have like the same function. Whatever. Let's make separate functions for now. And this one should be like end parentheses. It looks a bit weird now, but whatever. It could be some kind of pattern we could employ here, but whatever. I just want to make this work for now. End bracket. There we go. All right. Start end bracket, start end brace. Start end parentheses. Okay, let's make this up here. So make a function called start parentheses. Actually, let's make this errorable, because we might not actually. No, not errorable. This should handle that. Because we want to call this every time. If the current context is not the thing, then that's fine. I wonder how this works. I probably want to return a pointer instead. However, this should be a nullable actually. No. Yeah, because of that. I'll do like this, or else return null. Yeah, because the address of null doesn't make sense. I don't know. Okay. Now here we want to say if we have this, we get the context out, and then we also want to check if the context is equal to, well, let's do a switch and then string interp. And then we want to set, I don't know, why am I not getting completions here? Oh, because of that. Okay, there we go. It needs to be, okay, parent counter plus equals to 1. There we go. Yeah. So basically need to do this for every one. What you also could do is you could say, we can make a function here, and we can say increase. You can make a you can make like a, I don't know, counter type, which is an enum of, you know, parent bracket brace, and then actually this could be, no, yeah, you could actually, you could do this. Okay, let's do some comp time magic stuff. So we'll increase, actually, yeah, so we'll do this, and then we'll make a function here called get or set, and then self. Let's make string interrupt this. So we're naming this. This is like an anonymous structure, so to speak, but this will sort of bind. It will bind a name to it. This is like at this will be referencing the kind of current struct that you're in. So now I'm kind of binding a name to it, because if I use this here in this one, I think this is going to refer to counter type because we're in this type here. So I need to sort of alias this type here so we can refer to this type here, because I want to have self. I want to have like set. Actually, what you could do is also have this one here. You could, I guess, you could have set here, I guess, as well. Set, and then this would be like self this, and then we don't actually need this here. Okay, fine. But you could do it like that. You could do it however you want. Set, and then you have like a counter type, and value is the U size. Okay, that's the idea. Or you could just say inc for increase. You could also say field to get the actual field out. This would be a pointer to a U size, which is the thing you want to change, and you get the counter type. However, the counter type needs to be comp time, I think, right now. And what we want to do is we want to basically, well, it does need, actually it does need to be comp. Well, it's way easier if it's comp time none. So if it's comp time none, what we could do is this. We could say that we want to return the address of a field of self, and the name of the field is going to be the tag name of this type. So this will correspond to, you know, a string with this with parent in it. So a string with parent, and then we can append underscore counter. So basically we're building this field name here, or this one, depending on which one you put in. We're building up the different field names here. Okay, and we're also grabbing the address from that. So basically at field will access the field on self with this name, and it has to be comp time known, this name. So so now we can get the pointer to whatever counter we need, and then we'll make an inc function, and this one actually, oh yeah, also this needs to be a mutable pointer function, and this one as well. And here we will provide a counter type, and we don't really need a number here. We're just gonna increase by 1. Okay, so then we'll call like self.field with the counter type, and then we just do that, dereference, add 1, right? And then we'll do the same for decrease. Okay, there we go. You could also make this into a function, I guess, as well, just, you know, getting the name, a comp time string, and then you could use like at field here directly, and then plus equals 1 directly if you want as well. But this will make it so that we don't have to have 3 separate implementations. We can just use one enum to differentiate all of them, and we don't have to implement anything more here. So this is all now. We do have to implement more things here, but you could technically automate this as well if you want. But yeah. Anyway, let's go back now over to here, and we can say, now we can say, wait, where are we? Yeah, over here, all these things. Start paren. So let's actually do like start or inc counter, and we need a compound counter type, which we don't have access to. I think this is like context. No, where is this thing? Oh, it's on this one. I see. Let's actually just make this into a string interp context itself. There we go. And because now we can actually like say string interp dot context. A little bit of nested. Oh wait, why is that? No, not context. Counter type. There we go. Nested namespaces here. But anyway, so we're increasing this counter. Okay, we're getting this thing here, and now instead of doing this, we can just call inc with this counter type, and there we go. Now we just need one function to do this whole thing, and let's do the same thing here. Decrease counter, and we just call decrease instead. And you can even do that as well, but I wouldn't know how to call this function here. I mean, what I'm saying is you could say that, okay, the operation itself could be also be embedded in some sort of argument, and you don't have one function, but that's going too far, I think. So there we go, a little bit of comp time magic stuff there. Well, let's just finish this part first, and we'll deal with the other stuff later. So now we can say inc counter parentheses, and here is decrease counter parentheses, and so on. Decrease, decrease, increase, increase, brace, brace, bracket. Okay, there we go. totally maybe unnecessary, but I just didn't want to repeat myself 3 times there. Okay, so what is going on here? Switch must handle all possibilities. This was kind of what I was expecting before, but I didn't get it. But now we get it here. So all switches must handle all possibilities. If it's like a terminating type, I guess you could call it. So this is a enum, so we have to implement everything, which is very good. But you can just use else if you wanna don't do anything with the other stuff like it. So right here, what we wanna do is, if we have interp, we wanna do this. Otherwise, we could be. What could we be in actually? Could we be? So let's think about, like, when we end the interpolation expression, what happens then? Yeah, this is what happens. Yeah, interpolation end. But then we should be in a string context. So we should actually continue next time with reading a string token. But that, I think we already do that. We're checking here. If we're in a string context next time, we're doing that already. Yeah, so I think we're actually done here. If this is not the case, we don't do anything. We just fall through to do things normally. Yes, because you can't get here with a string context, actually. You're either in the interp or the root context. So there we go. All right, now we get a whole bunch of different errors here. Expected option type found this weird thing. Okay. Oh yeah. So. Okay. This is one of my gripes here with the standard library. There, like on this, there's no way to get a pointer to the last element. You can only get a constant. I'm not sure why. But always, every time you need to modify the last element, you have to do this, which is, I mean, it's fine, but it's also not great, and it might not exist as well. So basically, you could add a check here if we have. If the length is more than 0, no, if length is 0, then we return null. There we go. Otherwise, we do this. And we'll also guard against an overflow here. Okay. Or whatever it's called when you do like negative. No field named len in items. Yo, Zephlins, how's it going? Okay. Okay, we get some stuff here. Handle all possibilities. Right, so if we're in anything else, we don't do anything. Okay, there we go. Okay, what's this? So you see, we get 3 different errors here because we have 3 different. That usually happens when dealing with comp time stuff, because you get 3 different calls here with 3 different comp time values. You get 3 different errors. Found. So you want a proper pointer mutable. You get a pointer to a constant. I feel yeah. So actually you need to be that. Yes. Okay, so you need to add a little pointer thing there to make this refer to the original thing instead of a constant copy. Okay, expected error union type found that. Okay, easily fixed. And this one is ignored, of course. what is happening here? We're getting a mark. Where is the start? Start is all the way back there. Okay, let's see. What are we making? We're making the string text. And this is interpolation start. This is actually the end, right? So this would be the end. And actually we want to okay, I think this doesn't make sense. My thing here, this doesn't make sense. What is happening here? The location, I mean, okay, the end. If we're putting in an end, we don't know where we start. We're saying that we start at the current location. This doesn't make sense. We're never gonna have this situation here. Running a parser, yeah. I'm basically taking what an AI produced parser and modifying it. And right now I'm implementing string interpolation tokenizer. Let's see. Yeah, so actually we probably do want to make this a union event instead, actually. So now we have like start is a token mark. End. I'm gonna remove end. I'm just gonna have start and end, which will be a tuple of 2 marks. Yeah. There we go. And then start, you just put the thing there, it will make a start. You have to call this function differently than the thing, because Zig really doesn't like shadowing. This will return a start marker, end, start. I'm gonna call this start end, and this will be the start, and this will be the end, and start end. All right. Right. So now this is like, okay. Now we have to do this again. So finish dot start is gonna be finish dot start at, and now you do this instead. This is start end. Now we get the marker here, and here we get the markers. And actually, this is gonna look a bit weird. This is actually gonna be markers 0 and markers 1. All right. Okay. And so now we can say here, we can say start end and start end. What's the motion for multi-line edits? It depends on what you want to do. There are a lot of them. If you want to, let's say you want to remove all of the text, or I guess you can do. You can also change the command depending on what you do. So if you want to, what is it? All the lines that you're currently on, but they're separated by new lines. So if I do this, you can understand what I'm doing here. I'm basically removing, so DAP, which means like delete around, and you can see here paragraph. So P for paragraph, which basically is saying that it's gonna look for new lines upwards. Here's a new line separation. Here's another new line separation. So it will take all of this, or I can say VAP for selecting, or CAP for changing, or what else do we have? YAP for copy. So that's one. Or you could do, well, it's more like for like sentences as well. There's like, you can have sentences, but that doesn't really make sense in you know, coding most of the time. You can also, I usually say if I want to delete 2 lines, I press D and then down, then you delete 2 lines. Okay. Let's see, that was meant more like multi-cursor insert mode. Would I need a plugin? Multi-cursor insert. Oh, you're saying, or you're talking about this, like this, because that is built into Vim. You can say Control Q and then press down, and then if you want to insert some text, you have to do like Shift I, and now you can oops. Oh, now I messed it up here. But you can do Shift I, type in some stuff and escape, and then it will insert on all the lines. If you also do, you can do add, that will do it at the like the end of that. You can also do this, I think, which, yeah, appends to all the ends of the lines. That's all built in, like Control Q. Check it out. I think if you like Control Q, is it this one? No. Or Control V. Oh, there's Control V as well. I didn't even know about that. Or, well, it doesn't seem to do the same thing. Maybe it's Control capital V. No, that's paste. Okay, I don't know. But yeah, there, you know, I've barely scratched the surface. I've barely scratched the surface on what like Vim can do. I know there's like an infinite amount of possibilities what you can do with Vim, and I'm trying to, sometimes I go and look for, yeah, how could I do this or something like that. But it's like, oftentimes with Vim, you have to sort of read the docs and then figure out yourself. Most, like a lot of the times, you often don't get the answer directly. If you have an answer like, how do I do this? You often get the answer like, yeah, just type :help and start there. And that's not very helpful, you know. That's like, but yeah, I know there's like so many different things you can do, and yeah, as I said, I've barely scratched the surface on it. So let's see, expected location. Oh yeah, so this is like .lock. There we go. Okay, what? Okay, there we go. Area units in go. Let's do a try. All right. Okay, so that is. I think that's it for the tokenizer. Actually, yeah. So let's. So okay, now we got some errors in here, right? Because the parser thinks there are things called string literal, which there are not. We have string start. We have string end. String interp start. String interp end. This could all be probably, you know, automated with some comp time, clever comp time stuff. But and then we have string All right. Thanks for the tip. Just save me a good chunk of time while commenting. Yeah. Okay, another tip. It way easier way to comment out some code. Select with I usually use Shift V. I think it works with V as well. So select some text and then you press GC. Ta-da! And you don't have to know how to comment in the language, as long as Vim knows. What's good as well is you select the same piece of code, GC, it will toggle it back off. Very good to know. It took me like, I don't know, 15 years or something to know that. But it's just, I don't know. And maybe sometime I will go like through like a serious Vim extravaganza or something to learn more things about Sim. Or Sim? Vim. Zim. Oh man. I'm seeing it. Zim. The Vim version where with Zig as a language now. Hello Empty Code, how's it going? Thank you for the subscribe. All right, let's see. String literal tag. Wait, that's right. 1 second here. All right. Okay, so we don't have string literal anymore. We are going to have something else, but I will just do this for now. See, I'm using the GC there. How are you doing? I'm doing great. How are you doing? What is the font? The font is Hasklag or Hasklig. I'm not sure. There was a typo in one of the things, but it has it basically has like special things for Haskell type stuff. So if you have like equal but actually it doesn't really work too bad. Oh, there we go. This kind of thing, it like makes a special character for that. Or if you do it like this, the arrows. I just think it's nice. I'm not sure what the main. I think it's like it's based off something else, and then they added this, the sort of this combined stuff to it. Expected primary tokens. I'm just gonna comment this out, and this. And what is this? Oh wait, oh wait. Fail expected token string literal. What? That doesn't make sense. It could be. Oh yeah, well it does make sense, I guess. Let's do like string start, I guess. All right. Okay. Oh yeah, so here we actually need allocators. So let's put them there. And we're creating a lexer. Do we return a lexer, or what do we do with the lexer actually? No, we don't do anything. So we should destroy it. There we go. Anything else? You need an allocator now. There we go. And you also need an allocator. All right, that's it. Let's try this now. Now, first off, this is not gonna work. Yeah, it's like, what the hell is this? But then what you could do is you could say print tokens. Oh. Oh no. I think we're like in an infinite loop here. It makes sense that if we wouldn't get an infinite loop first, because it's like a streaming structure. So personally having a rough day. Oh, sorry to hear that. Hope it gets better. Are you a developer? I mean, you have code in your name, so I'm guessing. Let's see. Wait, what the hell am I doing here? Flexor, right. Wait, where was that? Right, unexpected. No. Ah, here we go. Expected token, not unexpected tokens. Expected. No. I need to analyze why we're stuck in an infinite loop. Maybe. Okay. We can do this. We can add a safety guard. We can add. Well, we have like max consumption depth. When is that actually employed here? It's whenever you call next. Right. I want to do this. I'm gonna add a safety rail for when we are stuck on the same index, which shouldn't be the case. That shouldn't make sense. Last index. Maybe we have like last index. I guess we start with null. And if we call next, if last index is equal to index, I guess we could defer this. If this is true, then we need some kind of error here, but we can't return an error in this case. Okay. Coding roughly for 2 years. Oh, nice. Been thinking about having more courage and just ignoring web dev and pursue my interest, which is game dev. You were kind of what I was in my situation a long time ago. I wanted to get into game dev, which was what made me interested in programming in the first place. But then I ended up in web dev because I don't know. I just got a job in there, and that's how I started that journey. But I ended up like liking programming just for programming, so it wasn't that bad. But always like game dev in the passion has been a passion. So yeah, that's a tough situation. Can you defer anything in Zig? Yes. I mean, okay, so what defer does is basically, well, you can't change the result, you can't change the return, so you cannot like, what I cannot do is return like an error or something else here. So in the defer, basically what it's doing is it's like inserting kind of code wherever you have like these exit points, there is return to do whatever you want in the defer. So if you want to have some cleanup or you want to do something else at the end, you can use defer for that. However, in my case, I actually want to check some stuff. So I think I want to do like, man, I want to do like defer last self, last token, or last index equals to self index. And if we are here and last index, oops, is still the same index, if it's still the same index, that means there's some kind of lexing thing that has gone wrong, because you should always increase the index, I think. So then we want to return an error. This should be like, I don't know, no index did not increase. It's kind of a weird error because it should only happen while like developing the thing. It's more like a debug message. All right, let's see if that works. Yeah. Or basically no. 0 new line 128 1821 tokens. Oh, that's the only token we got then. So we got to the new line. Wait, that doesn't make sense. No, it does make sense because we had some okay, so we have some comments. They are skipped, and then we got a new line. No, wait, we read the comment, we got to the new line, and then it failed here, I think, for some reason. Okay. By the way, I need to just be 1 second here. Let's see. Only use defer for cleanup, but their function already written defer body response. Oh, I see. Yeah, I'm pretty sure you can do whatever. I don't know Go that much though, so I shouldn't speak. Be 1 second here. All right. Let's see. Where were we? Right, so we got this error. This should be happening again, I think. Then, like, it should happen 2 times. Got a new line. Although we shouldn't get like a token new line. We should just skip that new line. This is on line 1. Like, we don't really need this new line in the tokens. We should just skip that whole line, I think. Right? Isn't that correct? We're peaking. Like, why are we not consuming this? Maybe it's because if you have another... no, okay. If you have another thing on, like, before the comment, like this, echo, we shouldn't skip the new line, because then that actually means starting another... This means starting another command here. So we shouldn't actually skip the new line, actually. Yeah, that makes sense. But why is it crashing out now? Because that didn't happen before. Seems like it defer any function and go. So what you can do is you just write an anonymous function, do what you want, and there you can defer that function. Okay, so you cannot defer an expression, like any expression. Have you ever heard of a certain goose? Have you ever heard of a certain goose? A goose. I don't know. I'm not sure what you're referring to. Would you say you enjoy this goose? I don't know what you're talking about. Sorry. I don't get this reference. Sorry. Total not a joke. Goose cult in a Discord? Okay. I'm sorry. I don't know anything about that. Goose cult. Is it an actual cult, or is it just a like a meme or something? Not directly, but you can have a function and defer that to pretty much achieve the same thing. Yeah. Okay. Interesting. Just need a screenshot of spreading it outside of Discord. It's a meme. One of the first man was named Goose Toe. Oh, okay. Okay. I see. Let's see here. Single chart. Okay, so why are we not then? So we should skip that, and then we actually get like a new line somewhere. Next new line, it's gonna be returned. We're gonna consume it. We are, maybe there's something with this one. I don't know. Oh, we're actually modifying this. Huh. Actually, yeah, I haven't seen modifications on the columns and lines. Where is that happening otherwise? 3 places where it goes to 1. Synthesize trailing new line. What? Oh, at the end. Okay. I see. And what is this? Advance. Wait, so this could be bad. Okay, we have to know that we are advancing in that case, or peaking. Here we are only shrinking. No, we are advancing. If the match... Wait, what the hell is happening here? We start, we consume. If it's this, and then we have this, we accounted for this by that in the advance, I guess. Oh, it's like consolidate, like, okay, so it's like if we have like Rn, n would have been, no, it's not consumed. Wait, this feels like this should be the other way around. Or am I crisscrossing my wires in my brain here? Yeah, this was handled in advance. New line already accounted for by /n. Oh, is that for the next match then, maybe? If we're advancing again? Okay, this one actually advances. Okay, okay, I see, I see. That actually advances. But if we only have a /r, basically what we're saying, we do this. But why wouldn't we do that in advance though? Instead of doing it here? I don't understand that. I mean, this is all AI generated here, so. Like you read defer func inside a function. Oh, I see, I see. You can do that, okay. Ever play old school RuneScape? No. I played WoW when it came out. And then I played that's the first MMO I think I played. I'm pretty sure. But I'm not big into MMOs actually. I don't like doing the same thing over and over. So I don't like grinding. I don't like that. How much progress have you made? So basically we made progress, and then I made some. Then I reset the progress basically, and now we're back to square one almost. No, not really, but we have. I'm building like the tokenizer here, and there's also a parser that makes an AST. There's also an executor that actually executes the script as well, the AST. But the problem is I started this project using AI, and I barely looked at the code and just asked AI to, hey, implement this, I want this feature, and it was like, yeah, I'll do that. And then after a while I looked at the code, and I realized that the AI had actually built in a totally wrong direction basically. So I'm trying to now manually fix the things that AI was doing wrong basically. So lesson learned that if you're gonna use AI, you have to be good at communicating with the AI, and you also have to be wary of what it does as well, and kind of change the course if something doesn't go how you want it to go. I would say, so anyway, I'm just reading this to try and understand what the AI is doing here. Okay, so far this all should work fine. There's something going on with the new line, so that's why I'm reading this here. There's some kind of error happening here. It failed to lex this script. Tokens index did not increase after this new line token here for some reason. So yeah. Okay. Anyway, we get a new line. We should start at the next here. That should be skipped with this. And then we should get another new line. So I'm not sure why it doesn't get another new line here. Doesn't make sense to me. And then we get, so we get another new line. I'm gonna check this out here. We're picking the next one. Unless the new line somehow skips past this. Skip line comment. Wait, so we advance on the new line as well? No, we don't. If it's a new line, we break, right? I see. And then we continue. We continue. Okay, so, and then we return, right? Okay, and then we go over here, and then we see that it's a new line, so we do that. Okay. Okay, this is where I really wish I had a debugger properly here, so I could debug this, but I don't have it right now. And I tried to make it work with NeoVim and everything, but yeah, it doesn't work. So I think maybe let's see if we can. I guess we'll put some logs here. We'll do like I'll make this log function. Log format time. This is the classic print signature for Zig. You have a comp time format string, and then you have the arguments, which is an edit type, and then you call I guess debug with format and arguments. However, I wish to add a little bit of context here, so I'm gonna say lexer and then index line column, and well, that kind of becomes a bit weird. I don't think you can you like make tuples? I mean, I know you can merge tuples. I guess we could do this as well. I guess we could make this errorable, and then we make a writer to stand it out, which would be standard out or standard error, or I don't know, standard error. Yeah, sure. And then writer. Do you need to be mutable now? And the buffer doesn't need to be anything. There we go. So that's the standard out. Okay. And then instead of log debug, we're gonna do try standard out print. Actually, interface print. And then we don't do this. we will say, because now the new line is not part of this, so we will say self.index, self.line, self.colon, and then we will do interface print. Is there print line? No, there's no print line. We will do print and then format plus new line and args. There we go. So now we have a log there. Yes, debug print. Hello Polaris, how's it going? What's happening with YouTube? They changed something because I'm seeing some weird handles. Oh, I just lost all the chat history there. Okay. Anyway. Yeah, debug print log. Let's see here. So we're skipping white space. I'll put that in here so we can see that. Okay, let's see how that looks. Error units ignore. Oh yeah, try. There we go. And we have to expand this error now. Writer error. Okay. Skipping white space. Index 0, of course. Yes. Should that really be increased to 2.1? I don't know. Maybe that's the issue. I'm not sure. Okay, so we're doing that. Fine. So apparently we're doing that. Lex new line. Let's check if we actually get here. New line. Try. Oh man. Okay. Yes. We do in fact get a new line, which should be returned then, and then we do the next one. I will add a log here. Oops. Try self log. Next. Okay, skipping white space, producing a new line. We could also add defer. I wish you could get defer, like if we defer, I wish you could, there's a version where you could actually get whatever was returned. Is that a, can you get that? That would be cool. I know you can with defer, I think. Defer. Maybe defer, but there's no, I don't think there's a defer with like the value, like return resume. What the hell is that? Wait, what is resume? What? Resume will continue execution of a function frame after the point of the function was suspended. Wait, is that some async stuff? Oh, that's async. Okay. Okay, never mind. Okay. So, but what I wanted to do was like get the return value. So if you could like, that would be cool if you could get deferred and get the value that was actually returned, and then do something with that at the end. I don't know. That would be kind of cool. Because that would be great now. Because I want to log whenever we return as a thing. But I guess we could also check where we call this. We do call it a whole bunch of times somewhere here. Yeah, I think, yeah, we have the stream as well. I guess we could call this here. Or here. Next, token. Now, do you have a format? No. You could actually add a format there, or you could also just say .tag, which should format it automatically, I think. Local okay. Next token. Oops. Wait. Try. All right. Wait, why is this working? I'm pretty sure we're using stream. What? This is in tech. This is all in like tests. Print tokens. Oh, I see. This is okay. So we're not using the stream here. I see. What if we do? What if we just do stream? Stream init instead, and we use that. Yeah. Okay, there we go. Now we can see that when we actually produce tokens here. Okay. So the token is new line. We call next here. And that's line 2, column 1. And then we failed because it wasn't increased. But it was increased though. That's the thing. Or was it? Wait. So it only succeeds once and then it fails. Presumably because the last index was null here, so it should just succeed. And then we call next again, then it immediately fails. So I think the problem is with the logic around last index here. Yeah, I think basically at the end of the function we want to check if the last in, so maybe, okay, maybe this is not the place where we do it. Maybe we do it in the stream then. It would be cool if you could return errors in the first, but we can't. So either we have to copy this at all the different exit points, or you could make a inner function like private next inner which does basically everything here. Whoops, why? Okay. Okay, something is weird with the brackets or braces. Log we will actually do that. We will call next inner return that. And I think here we want to check if, yeah, there we want to do this. No, here. Before we set update last index, we want to check, okay, did this actually increase the index? In that case, we're good. If it didn't, we have an error. Thanks for stream, I gotta go. Oh, yeah, thanks for joining. Have a good one. Okay, and then we update that and we do this. Okay, let's see how that works now. Interesting. We get to the end, I think, and then we don't, nothing happens. So the guardrail did not work. There's some I guess something happening in one of the functions. So now we can see we get a new line, we get a new line token, we get another new line token, we get a new line token again. Now we get the identifier, which is echo, string start, which is this one, and when we start to read this one, it all fails. Okay, so we know more about what is happening now, which is great. So we are actually, where are we? Here? No. Where are we actually? Here are we. Yeah, the first thing that happens is that we're in the string context right now, and we're doing this string text. And this one is supposed to, oh, I see what's happening here. So we're peaking, but we're never advancing, except if we are ending the thing. Right. Yeah. And this is weird as well. This should be like an error or something. I don't know. If we get here, we should advance. Every branch in here should like abort, return, continue, return. What's gonna happen here? This is just a continue, and this is a break. So if we get down here, we should actually do an advance. There we go. I think that's what's happening. Okay, there we go. Now let's see what we're dealing with here. Here's all the debug logging. Here's the actual tokens that was produced. We got 3 new lines. We're skipping the comments. We got an identifier, string start. This is perfect. String text. We got... we're missing the interp start. Okay. We should have an interp start here. And then you get identifier. So we're back to expressions. And then we get an interp end. And then we get a string text and empty one, which we could technically skip that one. We should also get a string end here. Interesting that it like didn't fail here. Okay. Oh yeah, the string end. We don't actually do a string end. We just do a string text and then string end. So we could say that, okay, if it's an empty string, well, technically, no, an empty string should not be a thing. Because we have string start and string end, so we know that it's gonna be an empty string anyway. It's just unnecessary information that you have an empty string here. So I'm gonna say that if let's see, the empty string, yeah, the length is 0. So basically, if start is equal to, I guess, the current index, then we don't create that. But if it's less, we do. Actually, we want to create 2 tokens here. That's the dumb part. Oh man. No, but okay. We do this, okay? If we have any type of length to the string, we now have a string token, but we don't actually advance this one. We shouldn't advance it. Okay? But if the length is 0, we should advance it, and we should also return finish start at mark, because we're marking like the current. No, wait, we need like start string end. And then the token is string end. Yeah. All right. Yeah, so and then the thing is then, like, if we encounter this while we have a string in a string context, it's going to produce a string end anyway. But this was one of the reasons. Yeah, because every call to this should produce a string, or I mean a... No, wait, but that... Hang on. Yeah, it should be a string end. 1 second here. Okay, this is getting a bit confusing here. We call this, if we're in a current, this is like the handler if we're in a string context. So if we are in a string context and we encounter an end, that should be the end. If we don't encounter an end, we should, So okay, I think we'll do this. I think we'll do a peek first here. We do an additional check. If the next one is this, now we make an end. We just make an end and we're done. And that should just be start here now. There we go. Okay, but if we didn't get that, we have actual additional characters in the string, and we will run until we reach this or something else. If we reach this, then we have a string, and we can simply return that. And now we don't actually have to check the index because we know that we have at least, you know, we have from this one we've checked that we have that. Also, this is shadowing that, so that's great. Could we block this actually to make it not shadow? Is that a thing? Yes. Oh my god. Okay, I should use that a lot more to avoid shadowing, because if we didn't have this, now there's an error. Because this shadows the outside, which I think is just ridiculous. This situation... okay, I'm not gonna harp on about it, but this fixes it there. Okay, and the only thing this is doing is like creating some. This creates like a little block scope here. It doesn't really do much, I don't think, other than for semantics for the compiler. I'm pretty sure. Was it like if you have a defer in here, it will execute at the end of the block here. Okay. So nice, that is now doing that. So we're checking for the end, because the whole thing here is like, if we reach the end here, we do not advance this one, because we return the token, then the outside will call next again. It will still be in the string context actually, so we don't pop this here actually, we pop this here. We pop the context here. We're still in the string context. We go in here again. Now we encounter this. We actually know already we're gonna encounter it. But anyway, we encounter this. We now consume it, pop the context, and we know that we have a string end. So now we should get a string end, even though we have like nothing between here. There. Okay, I think that should work. Hopefully. Okay, now string start, string text, hello, identifier, yes. Still need to add a interp start. We get an interp end and then a string end. Right, nice. So what if we add some text here? Then we get string interp end, string text, string end. Nice. Okay. What if this is a string as well? So this is the major, this is like the highlighter doesn't work here, the highlighting doesn't work, but the hopefully the tokenizer will work. So here you can see we got a string start, the text is hello, we got a well, okay, before we do this, let's add the interpolation start so we can properly see this. So interpolation start is here. We actually, oh, string text, why? Oh, I see, this is the string text part, and then we actually need to check for the interpolation start. Right, so we're advancing, actually we're advancing like 2 times. We shouldn't advance, the thing is we do want to peek ahead like multiple times, because we have 2 characters we need to check for, but then we want to backtrack, because the next time we want to read these 2, because or technically we could just add a flag, I guess. We could add another context maybe. if we're currently doing this but we haven't consumed, well, okay, has produced, this is kind of stupid, but has produced start token starts with false. And then let's see, where is the thing here? If context string, if the context, actually let's get the pointer. We get a context and then switch on that. Why is this? This never works. String interp. And has, if this, so if this is true, or I mean if this is false, this is so, okay, if we haven't produced the start token, we will set this to true now, and we will just return we will return finish token. So finish type should be start. The location is, yeah, this is kind of, this is bad. Maybe we'll keep this around actually. I guess no. Actually, what we could do, what we should do instead is like we need a place start marker, token mark. Yeah, we actually need this. And because we needed to keep track of where it was. I don't know. I might be doing this very stupidly here, but we need start marker start. Okay, and then instead of doing this, we will say if the start marker index is equal to the current index, that means nothing. We can't actually get there. We need like, this is going to be like +2 because that's the length of the start marker, or that's, yeah, for the start interp thing, because it's 2 characters. It's like this and this. So we need to check if this is, no wait, it's -2. Yeah. If this is this, then that means we haven't produced the start marker index or the token yet. Except how would we know that later? I guess we could put this. We don't do this actually. I guess we do this. Start. Yeah, if it's null. There we go. If we start. Yeah, there we go. So if it exists, we set this to null, and we use the value. So we return token, no, finish start at start, and the tag is string interp start. There we go. Okay, a little bit of weird gymnastics going on here, but we need a start token. All right, and you need now. We could use this one, and it looks weird, but yeah, should be fine. Yeah. All right. Then we have this part. Okay. Oh, yeah. So if it's anything else, we don't care. We'll fall through. Okay, that was a bit convoluted. Hopefully it will work. Oops. Oh, come on. Okay. Oh, error index is not increased. Okay, okay. Right. I think in this case it doesn't matter, so I'll disable that actually. It's kind of like we're ahead of where we should be. Maybe we should implement, instead of doing that, maybe we should implement like a backtracker instead. Like we could backtrack to the place we were before. I'm not sure. Or even better, peeking multiple characters. Yeah, that's probably that's probably the best one. Peek next is. Are these even used? Okay. Peek slice. Yeah. Length. There we go. I guess the length is known, so you could do some weird type here, but whatever. Actually, it's not known. It has to be comp time known. Well, anyway, whatever. It is comp time known though, because we know if it's comp time known. Anyway. Index and then plus length minus 1. Because if length is 1, we need that anyway. That's the normal length is 1, so we have to subtract the 1, right? If we have 2, that's when this value should start to increase. Okay, and then this one would actually be just this plus length. Yeah. There we go. Okay, so now we should have a peak slice. And actually, all that we just did, we need to undo. Okay. Well, not all, but where is that thing? Here, like this part. Yeah, I don't think we don't need to keep track of this start marker. We don't need you. You can be this now. You are not there. Yeah, we still want to do this actually. However, we don't need that. What we do want to do is we want to peek a slice of 2, and we want to check if this is equal to that. Oops. And if it is, then we do the token. We also want to consume. We want to advance 2 times that. Now you could have this expression, you could have this in a string interp, but that's an error. That should be like a weird error, actually. This should only be, no wait, this should only be in, this is kind of a weird thing, like this should only be possible in the string. Okay, whatever. Let's just make it work there. What is this now? Oh, equal. What? Start is here. String it. Okay, so we don't actually use that. And you are a nullable. Right. So I guess, or else we break from the switch. No. There's a bit of like logistics here. You can have a label here, I'm pretty sure. I don't know what the implications here is if you put a label here like this. I'm pretty sure you can. Maybe you can't, actually. No, you can't. Okay. I'm just kidding. But you can put a label here, I think, because this is a block, technically. And you can break out of the block. Yeah, and continue downwards. But it won't break like out of the if into another clause or something like that. Okay, but I won't do that. I will just do if we get this, we get a p. And then we have to do this. It's a little bit of nesting going on, but this should be like a function, or maybe this should be like a function like lex start interp or something like that. Yeah. The nice thing about this, you don't oftentimes need anything else than just lexer. Okay, yeah, I guess this is a nullable. Technically, we could do it here as well. We could have everything in this, actually. So basically, if we get this token, start interp token, we should return it. But if we didn't get it, we fall through. Yeah. Oh yeah, also here now we do a peek as well. So we do if peak slice 2, we get this here. Actually, you know what? Let's just add a convenience field. Peak slice is right, and then you don't even need a length. You can do like a comp time. Let's do a comp time just for convenience here. Comp time, some kind of string. This will return nothing, just a bool. That should be, so now length is actually s.length, and we don't actually return this. What we do is we say source is equal to that, and then we return if this is equal to s. Okay, then yeah. So now we can just say if this is this, you know, then do stuff. Don't advance. Don't do this. Okay. Don't advance. Push context, yes. Finish, start, end. We don't really need the end mark now, so we could just say start at start. There we go. Because the end is correct. Okay, yeah, that's way better. That's way easier. I will say false there, yes. Okay. Let's go back here, and now we can say pig slice is that instead, and we don't need this part. Should really, you know, always think about how to make life easier for yourself. All right. Okay. Are we done there? Let's see where we are. Okay. We have a start, which is here. We have the text. Hello. We have interp start. Very good. And now we have another string in the interp, and a text and an end, and we have an interp end, and we have an end of the string and a new line. So hey, it works. Oh man, that's and then you can even have, like, you know, another thing in there. That should all work. Yes. Yeah, interp start. Yeah, man. Okay, awesome. Do we want to try to get to the AST with this as well? Because the AST won't. Yeah, this will break down. Fail to parse, unexpected token. Yeah. So yeah, so it doesn't know how to handle string start. So I will. So now we need to figure out how the parser is gonna handle all this. Okay. And yeah. Okay, so hello, Elijah. Thank you for the compliment. I will take that as a compliment, because that's how I am. Okay, so now, yeah, the AST, how are we gonna deal with this now? So we this is the pipeline stage, right? Okay, I think so now we can actually, I think we can just say if we get a string start, we can basically just parse. So because this is like gonna be recursive here, we are going to parse the string. Yeah, I mean, we're basically gonna do whatever we're doing in here, except it's now, we now need to change the string literal. Yeah. Yeah, so that's good, great. Now we're in the string literal here. This is gonna be a lot different. Oh yeah, I was trying to do this here. Right. Yeah, because yeah, I was basically trying to parse that, like tokenize the thing in here, like build like a mini tokenizer here. This was really stupid actually. I should instead, now we have a bunch of tokens, so we can consume the tokens, and we don't. I'm not even sure if we need some weird state thing going on. I think it's just gonna be a recursive build up of these segments. Maybe each segment could technically be, yeah, text or interpolation, which is just an expression. So yeah, I think it's gonna be pretty simple actually. We don't need to keep a state going. We don't do this crap. I'm gonna keep this code here. Let's do like while true. And we'll get the next token. Parse string. Okay, yeah, and this doesn't make sense. We don't get a token here. That does not make sense right now. Also, what the hell is this? That's just a string. Okay. Expression, right. Well, I'm gonna do this for now. Where is that? There we go. Wait, this is called from here. Yeah, we don't do this. We just get that and use it here. Okay. Hello, Alex. Me7 Alex. How's it going? Or Metallics, maybe. I can't read. Create breadcrumb. Yeah. Okay. So we don't have this inner part. We don't have a token right like that. What we do have is here we get a token. We get a tok. This is kind of funny because this means, like in Swedish, this means someone who's a little bit crazy. And so, okay, but anyway, so we'll do self stream next or peak or next or peak or next. Let's do it next, whatever. Okay, so we'll get the next one. Now we'll check. Well, okay, so where are we with this? We know that this is a start, but that's only peaked right now, I think. So we have to consume expect, yeah, this, we're gonna expect this to be a string start first, so we'll skip past that. I'm making a compiler for my programming language, but I want to try create an interpreter as well. Yeah, cool. Awesome. I'm making I'm just making like a scripting language, so it's basically gonna be just an interpreter, not a compiler. I mean, well, I am technically compiling into an AST, but it's not going anywhere except for being executed directly. And I mean, technically, it could be like we could transpile it into something else, but yeah. Do you compile to an IR and running it on a virtual machine, or are you just executing stuff? Yeah, I'm just executing the AST directly. It would be cool to be able to compile it though, to make like a native. But the thing is, I mean, I guess it should be technically possible, you know. But the thing is, it's gonna be kind of like a bash-like language. So you can see here, this is actually calling the echo executable with some arguments here, or one argument actually. But yeah, I'm working on the string interpolation right now. Let's see. But it would be cool to make it into a compiled language. That would be pretty cool. I've actually done that before, like making what is it? Well, actually, I just made it straight into, I guess you could make it into like assembly and then compile it from there. That's an option. Yeah. Or you can transpile it to C or something like that, or Zig, or yeah. IRL allows you to do optimizations, we can hold on. Yeah. That is true. I mean, yeah, the optimization, like there's so many things you can do on multiple levels, and so, but yeah, it's I guess, you know, modern language now usually take advantage of like LLVM, but I think Zig is actually moving away from LLVM because it's too slow. So I don't know. It's just a toy language, so it's not really gonna be anything, you know. It's just like a hobby right now here. Okay, but anyway, so let's see. If you're building AST, you can translate it LVM iron. That's it. You wrote a combine. Yeah. I would have to learn how to do that though. I haven't really learned. I don't really know that. I've looked a little bit at LLVM IR and it looks kind of crazy to me. But yeah. Okay, so we get a token. So string start should be cool. If we, okay, so this is pretty easy actually. We're just checking the token tag. If it's a string text, we just do this. We just append the thing, and this one would be the lexeme here. So that's super easy. All right. So now we should support strings. So I will do this, and it's having trouble with. This should support strings now. Oh, we got some errors. Never mutated. Right, this is never mutated. And you don't exist. The span. Okay, yeah. The span should be like. I guess this would be the start here. Start token. That is the start token span, and then we end at. Wait, why am I? Is this a try? Okay, it's a try. There we go. So span and that, and then we get like, I guess we get like the last item in the segment. We could have an empty thing though. So let's do like end is segment items. So if this is 0, that means the end should be start token. Otherwise, or yeah, start token dot span. Otherwise, we should have segments. Well, actually, I could just get last. Okay, but then you could actually do this. Get last or null, and you get the segment out like this. Okay, I should make a span function there. Otherwise, it's the start token. It's much easier to do code gen yourself. I mean, yeah, sure. It's so complicated to me because the API tells you how you should pass things. It's assembly levels, kind of complicated structs, implement only passing pointer to structs. Yeah, I understand. No, you got great English. Yeah, but yeah, I do understand. I don't know. I went through like implementing a very simple language that could compile to. So I had like an intermediate assembly language that I compiled to, and then that I made myself, and then I also made the compiler from that to machine code, and also the binary. So I made all those steps from scratch, and it was a really interesting experience. But it wasn't like sophisticated. So basically, it was just like very simple. But I did all the steps, and I expanded on it. But I could see that well, this could get very complicated very fast. And basically, not really any optimizations or anything like that. Basically, just we're supporting super simple stuff. But it was a very interesting experience. But yeah, I do get why people want to like have some sort of construct for that to make that easier. But it was fun building it, and you do get it. You do get like an appreciation for everything that's happening under the hood and stuff. So, and not to talk about all the different optimizations that happens for everything that happens in like Clang and the LLVM and stuff. So it's like there's so much stuff there, and also debugging is one huge part as well. Hello, Mirror Cat the Dev. How you doing? That's also like a whole chapter in itself to add like debugging information into the executable, and I never really got around to actually implementing that fully, but so there's a lot if you want to do that. Which It was fun, but I wouldn't complete a project like that. I would probably use something instead in that case. But you know, it's all up to oneself to how you want to do it. Basically, I mean, it's a nice learning experience. And sometimes you do get the feeling, man, I could just do this. I'm gonna make it so much you know, more optimal and better. But you know, then you realize that, well, maybe not. Okay. Switch my sign over possibilities. Yes. And okay, yes. And is this okay? So we need to implement this part, which is here. So let's just add a function span segment self dot. So either we have a text. Then it's just gonna be, oops. Why is, oh, wait. Now this should have a span, yeah. Span, I do have a span type somewhere. I'll make it, I'll put this here somewhere. There we go. Yeah. It's a little bit nicer to have it be why. Where did it go? Oh, this is the AST. Okay. The token has the thing. Okay. And you. Okay, sure. There we go. So now it's spanned. And we get a span. And then we have the interpolation and I'll just call this S. I usually want to have like the same name. And you should also have a span. Actually, you have a function. There we go. Okay. Okay. Back to the parser. I'm doing good. I can see that you're a dev. Are you? Do you have anything on Zig? Let's see, span, yeah, span, of course, this is now imported like this. All right, back to here. So now we have this function, we can get the span, so that should be end of the segments. And then we have this span here. I wonder what this does if it's like an empty. Okay, then just does this, okay, cool. But the address of this one, this should be like, shouldn't this just be this? I don't know. Okay. It doesn't matter, I guess. We're not gonna access it anyway. Writing compiler definitely may be better in programming. I'm making my compiler in C and implementing very convenient hash tables if you can really find anything useful. All right, cool. I'm often with Zig. That's interesting. All right, yeah. I think it's really cool. Let's see if we get this AST working here. Right. So we're looking through the tokens. Okay, yeah, so if we're encountering a string end, that means we should return, that means we should end this thing here. the end we break from the while. If we are at the end of file, this should be like an error. How do we like fail expect? Okay. Yeah, you could do that. You could do like fail expected. Expected tokens. String end or interp start. Cool. This just ends. Okay, and then we have an interp start as well. So interp start. Now this one, we're actually, this is like recursive here. So we'll do like append. And this one is interpolation. And this one is gonna be self, try self, expression something something. It's kind of like, no, it's just an expression. Yeah. It's an expression. Yeah, it's just an expression. The thing now though is we could encounter an interp end. Where do we handle that? I guess we handle it here, or we handle it here, but we probably need a context then. Is that here? Like an interp depth or something, I don't know. The thing is, the tokenizer should be correct. Like the start should always match with an end. I tried Sig when I was looking for a programming language at low level and has big standard library. I found older which is easier to me than Zig, so I learned it still using for making use. Oh, okay, cool. So you're a game developer? Hello, Mandarin guy. How's it going? All right, going good. Great. I'm doing great. Just implementing some scripting language, talking about programming. Okay, the interp end, when should that happen here? How does it work? So first you have this source code. Let me, wow. Yeah, so basically this is all comments, so this doesn't do anything. But we have the source code, and then usually you have a tokenizer or lexer, sometimes called, that will turn these separate individual characters, ECHO space quote H and so on, into tokens, so-called. And the tokens basically make it easier for us to parse the code. So we have this one will become a identifier token, this whole thing here. and then we have a quote token or string start token, string text token, and then string end token, and then you parse those tokens, and you build up what's called an AST, an abstract syntax tree, which forms kind of a tree-like structure of the program. And then you can use that in many different ways. One of the ways is to execute it and just run the code as it is, which is what the purpose of my program is going to be. So is it like a program decodes code? Yeah, you could say that. It decodes it and it also runs it as well. This my program is what it's gonna be. An interpreter is what it's called. So it's kind of takes a source code and just executes it immediately, basically. That's what you usually mean with an interpreter. A compiler is more like taking this code and transforming it into machine code that the computer then can read and understand and execute. And then you don't need an interpreter to actually execute it. You can just run it with a operating system or the computer. Isn't that easier to parse hello as string hello, not a string beginning hello string end? Yeah, okay. It's kind of interesting because that was how I used to have it, except it wasn't me, it was the AI actually that had built the foundations for this. So the AI actually made this whole thing into a string token. But the problem is that I want to have interpolations like this. So you could have an interpolation here with some sort of value. So let's say you have well, let's make it more like this. So I have a variable here that is set to world, and then I want to be able to interpolate this in here. And seems a bit illegal. What do you mean? I don't think it's illegal. Okay, so here, so I was struggling a lot with how to actually do this in a good way, which is also recursive, so you can have strings in here as well, and also like further like nested interpolations. The highlighting doesn't work here, but the syntax highlighting here, so that's the colors are a bit weird because they don't support this. But but right now this is how it works. Yeah, they are more complicated. I also toyed with the idea of actually doing something like this instead, like you had some kind of special function that would, do something like this, and then you would say value like this instead, because that would bypass this whole parsing part of the interpolation strings. So because then you just need to parse this as a normal string, and then technically you could also turn this into kind of like an AST where these are markers. You get these marks out of the static analysis from this, but then you wouldn't be able to use, you wouldn't be able to dynamically create these strings. But anyway, this would be like a way easier way to do it. but it also, I don't know, I just wanted to make it this. So this is like harder to use in my opinion. This is more clean to me. It's also like how Bash looks, so it's more like, you know, more like how Bash does it, which is kind of the point of this language. It's going to be like a Bash-like. It's kind of like a combination of Bash and Zig. From what I understand, it's like reading code that you don't have normal access to, like games or apps. Well, technically, it's not, you know, you can read any program you want. You can actually, you know, you can open up, you know, there's tools and stuff you can use to read the code of any program you have. And it's not illegal. Because it's like, it's just things, it's on your computer. I mean, it's compiled code, so it's compiled down to machine code. So if you have a decompiler, it's gonna try and parse that code and create like a, either like a you know, a readable version. It tries to make a readable version of it, but it, you know, I can assure you it's not illegal. You know, I'm just programming. Reading code that you don't have normal access. No, but this is the other way around though. But because this is, I'm writing this code, and I want to make this code run on the computer basically. I want to make this code do what I want. That's what I'm trying to do. You prefer printf because you're used to it. Yeah, I know. It yeah, I think it's what you're used to basically. But this will allow you to have all sorts of things in here. You can have a whole program in here if you want. But it's not gonna be maybe ergonomic developer wise, but whatever. Okay, anyway, let's see. I'm trying to figure out how to deal with the end of the interpolations. That's gonna pop up. Maybe I do need to have a context in the parser where we keep track of how many interpolations we are currently in. Perhaps. I think that's what we need actually. So interp counter. Let's just have an interp counter, and then where would we encounter it? We basically encounter it anywhere, like in here. I think we're probably encountering it over here somewhere in the pipeline. Yeah, we're gonna encounter it somewhere. Where is the thing? Pipeline stage. Here we go. Yeah, here's all the different things that can end the pipeline. So this would be a string interp end. There we go. So if we get that, we're just returning that. We're not consuming it or anything. And then what's happening later is we probably want to check skip nested structure. No. Parse. I think it's like parse statements. You can read machine code and even translate it back to AI assembly and then back to source code. Well, too messy. Yeah. And in fact, if you want to learn programming or learn how the computer works, then it's a cool exercise. I mean, it's kind of, you know, you have to, there's a lot of layers to it, so, but Okay. Skip new lines. Parse maybe let. Parse statement. Okay, I'm just trying to think like where would this happen? It wouldn't be in a statement. We would be in an expression. No. We would be in a not a let. No, it's gonna be an expression. Yeah, it's gonna be an expression. It's gonna be an identifier expression. Yeah, we're back here actually. Pipeline. Okay, so maybe we'll do it here then. We're reading the stages. If we're reading a pipe, that means we want the next pipeline. I don't know, we probably should put this in a more central place, but I will put it here. If this is the end of a string interp, we want to say interp counter -1. If that fails, it's gonna crash the entire thing, so that's fine. That will also mean we should do this part here. So actually, we probably want to get the token there and say if this is equal to that, then we do that. Okay, and in the start we will do I mean, I don't know if we actually need this counter. It's just to make sure that nothing weird's happening, I guess. All right. Text interpreter. Okay, so if we get anything else, what does that mean? These are basic. I think these are the only things we should be able to get here. If we get something else, that's also, this is actually, we could do else here actually, because yeah, it's, we can't just end the open string. It's like you have in this. This is not this is not correct here, and then you get a new line or something else happens. Like this is not how you're supposed to have it. This is how you're supposed to have it. Okay. Parsing expressions is one of the most complicated things to me because you need to respect operators' precedence, check calculated types. I spend a lot of time debugging. Yeah, it's yeah. Depending on what you want to do, it can be super complicated. Which I mean, it makes sense because it's gonna be as complicated as what kind of code you're gonna write, basically. Well, not really, but describing the code that you can write is oftentimes pretty complicated. String, okay, text, and then this is and we have a span where the span is just gonna be the token span. All right. The end is going to be used here. There we go. All right. Oh, we've got something here. Render string literal. Right. So this would be that. Invalid. Okay. Let's see where this error is. Main utils. Oh, yeah. so this would be also like payload. There we go. All right. Okay. Still get an error here. Unexpected token, expected identifier. Blah, 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 blah. String start. Okay. Still didn't fix a bug with binary unit operators. You can't combine in a particular way for some reason. Don't know how to fix it. Yeah, those things that's tricky. I think a lot of programming languages try to fix it with like some kind of, what's it called? You know, what is it called? Priority. So you would attach some kind of priority to each operator, and the ones that has, and then I think I solved it. This is probably a stupid algorithm, but I solved it once by attaching a priority to each operator, and I think I grouped together the ones that had higher. Wait. I think I grouped together between those that had like higher priority, and then just recursively did that, going down the priority list or something like that. I don't remember exactly, but or if my explanation here makes any sense, but yeah. Fail to parse script. Okay, let's not do this here. Let's actually do something way easier here. So I will do this part. Okay, well it still fails here, but it does work for. Let's just make it this work. Fail to parse. Also, how can we be at line or index 100? I guess index 100 makes sense, but line 100 did not make sense. I read that wrong. I'm gonna remove these debug logs here. If logging enabled, turn okay. Index did not increase on line 9. There's no line 9. It should be like end of file. This is weird. Okay, let me just add. No, it's still. Yeah, now it says line 10. It didn't increase, okay. Are we still trying to read the next? Maybe the parser is trying to read past the end. No, the tokens. Yeah, the tokenizer works. But then this tries to read past it, and then that's why we get indexed it on the crystal. We should get like end of. We should get some other error actually. Like if you're trying to read and we're already at the end, we should get something. We should get another error. Since you're writing an interpreter, you will need to write a garbage collection. I have no idea how to implement that, so I want to try to write it. Yeah, I mean, no, I think, I mean, I think I'm just gonna use. Okay, first of all, the AI has already written some kind of executor for me, so I'm gonna go in there and have a look But basically, I'm just using, you know, the Zig's allocation stuff for that. There's an executor here. It's gonna be this one, or maybe not actually. Where's here execute? Is it this one? Yeah. So yeah, I haven't looked at this at all. This, but it seems to work for now. Yeah, we have a bunch of statements. It just goes through the statements, and we're running the statement, execute statement. We have expressions. So we have all these different things. We have the pipeline. This is where it executes commands. And so actually, everything already, like all the strings exists in the AST. Like all static strings exists in the AST. If there's going to be some kind of a dynamic, like let's say you have a result from one pipeline to another. I'm actually not sure how it does it. Does Zig have some sort of allocated work like garbage collection? You can use okay, so what there is that either you could manually do everything, like manually allocate everything and have to free it up manually everything. You can also use what's called an arena, which is basically it's like an allocator. It's like, you know, in C you have malloc, which also uses, you know, some kind of algorithm for trying to do it in a good way. But an arena is basically this, you know, it's just a struct that will keep track of what you've allocated so far, and you can call the initialize on it, and it will free up everything that it has ever allocated. So that's a way of, let's say you have like an object, yeah, arena allocator, yeah, you have an object and you allocate a bunch of stuff on it, and then when you're done with the object, you can just call the initialize, and it would free up everything it has used. So that's a really nice way of using that. Yeah, and it also, like, it frees up everything you have ever allocated to that arena. So even if you let's say you initialize the object first, and then you may do other stuff like adding some strings or adding some other stuff to it, and then when you want to do away with those, you also just, the only thing you need to do is to initialize the arena as well. So yeah, pretty good. And I mean, technically you don't actually need to free up anything, because at the end of the process it's going to be automatically freed up by the operating system anyway. But it's just if you want to keep memory leaks, like if you have a long running process that you don't want it to the memory, if you don't want to leak memory, then it becomes important, because otherwise you could just create one arena, allocate everything to the arena, and then deinitialize it at the end of the program. But that doesn't really do anything basically. I prefer never freestyle. I have global variables like a symbol table. I use dynamic arrays that grows and initialize automatically. Alright. But I mean, I think you could probably, I'm not sure how easy it would be in Zig to implement some sort of automatic reference counter or something like that. Maybe, I mean, you could probably, so let's say you have like a pointer or like a struct that has a pointer and a reference count, but how would you know if, like, you still need to do something in order for the reference counter to actually like increase or decrease? I guess you would maybe use functions, some special functions, something, I don't know. But basically what Zig does is you have these differs, so it's a lot easier to know or to do these things. So here we initialize an array, for example, and here we deinitialize it, except it's not here we deinitialize it. We deinitialize it anytime we exit from this scope. So it's kind of like a destructor in like C++ or whatever. You have a something that gets called, if you have a in C++, if you have like a class that is on the stack, I believe, if it's on the stack, an instance on the stack, whenever that scope ends, it's going to call the destructor on that, I'm pretty sure, or when you delete it, I guess. But this is like this is saying that, okay, whenever this scope ends, run this code, which will free up this array. So it's kind of like, you know, we're not getting automatic garbage collection, but we can do nice things like this to make it a lot easier to keep track of what's happening. Because otherwise you would have to have this code at every exit point of the function, and it's just going to be a mess. Or create like a I don't know, some kind of wrapper function or something that does the wiring up and stuff, or allocations and deallocations. All right. Okay. Well, I need to focus here to see. Well, I mean, what I mean is I don't want to look at the command runner right now. I want to look. I want to solve this issue here. So why are we getting this error here? So it's basically saying like at the end, right? So I think it's because the parser tries to read more than it should, and when that happens we should return an error. So I'm just gonna see why we're not returning an error actually. It's like if we're next thing and we're at the end, that should be like an error, not this. I don't know. Maybe we're doing this because of how the scripting works. But if we already, if we're like past this ghost new line, we should, this should be an error. Will this actually increase? It does increase the line and the column. I think so we're at the end. This should probably increase the index as well. Maybe. So here, for example, I can use defer self-index plus equals to 1 because I'm using self-index here, so I don't want to change it, but I do want to change it at the end. Okay, and then I'm gonna do is at end really and this is gonna be if index is equal to this plus 1. This is gonna be equal. This is gonna be that. I don't know. That's fine. Well, let's actually do like more than or equal to plus 1. So here it's like if, whoops, if we are really at the end, we're gonna return an error. No, we're gonna return the end. Start end of file. But here we do get an end of file. Yeah, this means we already got an end of file. Oh, I think it's already done here actually. I zero initialize a dynamic array when append is called. The dynamic array is empty. Pointer is null. Allocates memory. When count capacity, I just reallocate and that's it. But what about freeing though? So I don't need to use the init function. Yeah, but that is okay. So the thing that I showed you here, it's kind of funny actually. Where was that? In the executor. This thing. No, where was it? Pipeline. Yeah, this thing here. This is actually the old way that you do it. Like if you would do this now, you would say array list, whatever, command spec, and then empty, which is just it's kind of like what you're saying here. It's a list, dynamic list that will initialize to some kind of null pointer or whatever, like an undefined. It doesn't have any length, and then when you want to free it, you pass in the allocator, and then we'll check if it has any length. It will free it. If it doesn't have length, it won't do anything basically. If it has length, it will free it. If you append to it and it doesn't have any length, then it will allocate, or actually it keeps track of length and also capacity. So if it doesn't have a capacity, let's see. Yeah, if it doesn't have capacity, so here we are ensuring that we have capacity for this new length that we need, and that will in turn maybe call allocator depending on if our capacity is already, you know, what it is. So basically you have length and capacity. There's another guy on my YouTube feed making Zig plus Rayleigh platform. Oh, cool. Hi, can I exactly what you're doing? I'm sorry to make you repeat the same thing. Yeah, sure, no problem. Let's see. 1 second here. So what I'm doing is making a new scripting language that will basically work like almost like Bash script, but it will have some more, I don't know, more, I guess, programming friendly syntax. So you can have, you know, typed variables, yeah, string interpolation like this, of course, which is already available in Bash script, and you can, you know, pipe this into other stuff. So this is basically like a Bash here, except with a slightly different syntax. So basically it's gonna be like a combination of Zig and Bash basically. And right now I am I am working on the string interpolation for the AST here. So whoops, that's not correct. Yeah. Hey, Nab Gaming, yes, I do remember you. I am still doing this. Although I will quit here in a second here, or in a moment, because I will have to go soon. Alright. Let's try and make this work here. So, let's see. Okay. Thank you also, Funky Lime, for following. Alright. Okay, so there is an issue here where it's saying some weird stuff here. Failed to parse script, line 6. Oh, unexpected token. Okay, yeah. So I will actually do this for now, and just try to do this here. And there's still unexpected token over there. So I will actually just try to do this first, and this results in index did not increase, which indicates that we're trying to read past the end of file, and I don't really understand why. Here it should fail on anything that is not this. We should have we do have like breadcrumbs for the parser. So I don't know why it doesn't show that. Failed to parse script. Expected tokens, like where is the breadcrumbs? Write the trail. Okay, so it does write it here. Yeah, because it is saying, no, it doesn't say anything. Okay, failed to parse script. Failed to parse script. Expected tokens. Ah, okay. So if it didn't have expected tokens, it just exits. I see. I see. Well, we don't need this. We don't really need this thing here, I guess. But if we did, we still want to do this though. The breadcrumb trail. Parser. Yeah. Writer is that. It's not marked public. Easily fixed. Let's see. Nice. What will for loops and if statements look like? My threshold from switching from bash scripts to Python dealing when I need loop or conditional, never like bash control. Yeah, that's basically why I'm doing this. Also answering your question there, Metallics. What is it going to be made for? It's going to be embeddable. I mean, it's basically just going to be you calling this script with the executable, and it will run it like a bash script basically. So It's just gonna be for, it's basically how you're gonna use like bash scripts. Basically, you could I want to use it's personally for me, and I mean of course others can use it as well, of course, if you get to that point, but I don't know, I just the syntax every time in bash I need to look up how to do this, how to do that, the syntax of loops, syntax of if statements, like I just can't ever get that into my head, how all the different kinds of how that works. So I basically, okay, well, I like building languages, I'm learning about AI tools and stuff like that, so I just, hey, go ahead and try to make a language using AI as a helper. So AI is like made the foundation for the project. So I'm basically, but then the AI basically didn't really do what I wanted to do. So that's why I'm doing things manually now. And then, yeah, so hopefully it will become usable at some point. So the loops, this document is not really, you know, super up to date, but basically it's gonna be the same as zig here. Here's an example of an optional. So this will become like an optional. I'm not sure this. Never mind this. This is just an example, like it's not like it's gonna look like this. I don't really know exactly how you get environmental variables, but maybe not like this. I'm not sure. But anyway, let's say this is an optional int you get. I'm not sure why it's an int, because it's an environment variable, so it should be like a string. But anyway, this is a port, and then you have this if, maybe port. So this is like how Zig does it. If you if on an optional, you can capture the unwrapped value like this, and then you can use it in this block here. And then you can have that. So basically it's gonna be sort of a mix between Zig and bash, basically, because I like Zig. So, and then so that's if. So we have loops, also basically gonna look like Zig here, for example. And if you're put off by that, because then you need to go and learn Zig. But anyway, so here's like, this is also not really, I don't think this is how you're gonna do arrays. I'm gonna do it like Zig, so this is actually gonna look like this. Okay, so this is more like a tuple. Actually, I'm not sure. I don't know. We'll see. Because I want it to be consistent with the syntax of Zig, but also not exactly like Zig. So it's like it's gonna make sense in some sense. We'll see. And then you have like, here's the for loop. You're basically iterating over these over the items in here, which you capture out here, and then you can also optionally have an index. So it's basically exactly like Zig here. And then you can use both of them in this block here. It's going to be possible to compile a language to bash or Windows bat file. Maybe. That would be a whole different thing. I'm not sure about Windows bat file. I'm not sure if that's possible. Maybe. I don't know. It depends on what kind of features I want to add and stuff. I'm probably not going to go that route. I'm going to go more the route of this being able to call bash files. Like one idea is this, like, where's the thing? Like bash integration. Where is that? Like you embed bash in this language, so you would have, you know, bash, and then here's your normal bash scripts. Yes, I'm still coding. Okay. Anyway, let's see if we can if we can fix this here. why are we not getting the thing? So the breadcrumb trail, okay. Let's see if we can get the breadcrumb trail here. Oh, there's no breadcrumbs. Okay. So that means we're out. Okay, that means we're... Oh. 1 second. Alright, sorry. Let's see. Parser. It's been 6 hours. Yeah, I mean, normal working days, 8 hours. Yeah, but I'm gonna quit soon here and eat something, I think. I have been drinking water, so. Do you want to make it multi-platform or something gonna be for Linux? I mean, it's gonna. Okay, my stance on that is this: it's like Windows actually has, you know, PowerShell. Even though I don't really ever do any PowerShells. But I think it's more consistent in the syntax than Bash. And so I think that it probably doesn't need replacement as much as Bash does. But there's probably other replacements though than I don't know. As I said before, like I haven't really looked up if there's any like replacements for Bash scripts. There's probably a whole bunch of other. I mean, you could use whatever, you know, you can execute Python scripts or whatever. But the point of my language was basically that you could use, let's see, like process. So basically, you're gonna be able to, like, let's say you want to call this command. You don't have to say like command, you know, something like this. Weird syntax to be able to run the command. It's going to be super easy to just run the command like this, and then you're also going to be able to use the results of that in an easy way is the idea. So basically, yeah, just a first-class citizen or whatever you want to call this, like it's going to be super easy to call commands and then do stuff with the results, and yeah. I need to work on the string interpolation, yes. Okay, I'm trying to figure out why with this error is happening. So, breadcrumb trail. Yes, we don't get any breadcrumbs, so that means we are in the... We are basically in the... I mean, so here we have no... So this is the entry point of the parser. Basically, we're parsing a script. We're getting some kind of script in. I guess it's part of the struct, whatever, because you don't pass anything here. You initialize this and then you call parse script. The script is basic. Yeah, it's probably. Oh, it's like a token. Okay, or you get a bunch of statements. Oh, spam. What? Oh, I see. Wait, what is this? No, this is the result. What the hell? This is the thing. Okay, yeah. So you have the source, you have a lecture stream and stuff. So we're using this to parse the thing. Okay, and so you call this. This is called from like when we wanna get the AST here. So this just produces the AST. So at the start, the breadcrumbs are empty. Okay. So I don't know what's happening. We're doing this, the breadcrumbs here. We are parsing until, so anything that happens in here should have breadcrumbs. So that's why I'm confused. Is something happening after this? Like we're printing the AST. Here, so we're going in here, we're trying to do this, but then it should, yeah, it gets an error before that. We cannot print, fail to parse a script, which is here. Let's see. Failed to parse the script, and it's at the end, which is super weird. Oops. Yeah, I wish I could run a debugger on this. Okay, let's do the same thing as let's do the same thing as we did with the tokenizer. We'll make this log function in the parser. So I'll just put this over here. And then this would be a parser, and we also need logging enabled. Then parser. Okay, what can we do here? So we do have like stream. I mean, I guess we do have these things. We do have like index, line, column, okay. So the idea is that you know, you could call, for example, here log, whoops, and then like parse script, or just script, because we're in that context. And then if we now build, we get an error. Try, and now that should be included there. And then we run what? Oh, login enabled should be true. There we go. Now we get this log here, so we can debug logs and stuff. You tried to write a compiler that compiles the program language of Bash. I thought a deeper and writing interpreter would be much easier. Yeah, so if we want to write a compiler that compiles to bash, you still need a compiler, you still need a programming language, you still need a program language, you still need like a tokenizer, AST, like parser into AST, and on top of that you would need a compiler that compiles the AST into bash. I mean, one thing maybe you could do is to make it easier is to make a preprocessor maybe that doesn't give you the same kind of safety as a full-on like compiler or interpreter does. But that could definitely be a thing, making some kind of a pre-processing language, but it also limits the amount of diagnostics you could do as well, because I do plan on having a little bit of LSP support for the language as well. Like we have a basic LSP right now, but it doesn't really have any features or anything. It just runs and connects to NeoVim. And I've been trying to get it to work more, but it doesn't really do anything right now. But I'm gonna try to make the AI make it work better. We'll see. Okay, so yeah, so parse script, parse statement until basically instead of using the breadcrumbs, I'm just gonna do this here. Statement until parse a script, skip lines until. I'm not gonna print everything. Probably print here though. Oops. Parse. Okay. Skip lines until. Oh, we need to try. All right. Skip new lines. Blah blah blah. Append. Peak delimiter. Parse. Here's the parser. Okay, yeah. So this is like parse statement. Statement. Okay, let's see how far we've. Okay. Yeah, try. Only one statement. Okay. Maybe let. Should probably just make that part of create. Actually, that's probably a lot better. Yeah, let's just do that actually. All right. Well, oh, but now this is okay. What? Wait, why doesn't this work? What? Oh. Bread, crumb, self, okay. Oh. Try, oh man, no. So this would be that first and then try to. Okay, there we go. And build. Okay, so now it's gonna print every time. No. wait. We need. Okay, I forgot something. I actually forgot. You have to flush. What? Wait, did this turn to... Oh. Oh, but it did work before. Or maybe we flushed it before. Okay. There we go. All right. Let's take the script up here so we can see it. I'll do this as well so that we get like the least amount of complexity here. So parse script, yes, statements, skip lines until parse statement. It's not a let, so we parse an expression, identify expression, yes, a pipeline stage. Yes, so we get this pipeline stage includes the identifier, then we have a string literal, and we consume a statement terminator. Okay. Interesting, right? Semicolon or new line. Which should be correct. Oh, so it's happening here. Okay, so that's the last thing that happens. Return statement. Oh, wait. I know what the issue is, I think. Man, it's so simple, actually. Hopefully. I think the issue is that when we're doing this shit here, we don't actually increase the index. So the next time we're getting, first we're getting the new line, but then we get the same index except the lines has changed. So basically the index stays the same. So either we can increase the index here manually, but I am increasing the index here though. I did add it. Okay, now I am confused. Now I am confused. Let's enable logging there. Oh, weird. It actually compiled. Okay. Skipping white space. So we're skipping white space and then it ends. Right, because we're here and we're returning this. I'm gonna add a log here. Synthesize. What? Oh. Alright. Where is the synthesize? Oh, needs trading new line. I see. Maybe this is not set. Okay, whatever. We get it in the file. But I guess here we don't actually increase the index as well. So let's try that. Okay, there we go. It works now. Okay, it was this stupid guardrail that I put in there. Okay, cool. All right, so great. Okay, now, okay, last thing I want to do is, let's say we have a value here and I want to interpolate that in there. Now this fails because there's some kind of parsing failure in the string here, so I would have to look at what the issue is. And try to run it, and we'll see how it will work. So it's gonna be some kind of that's gonna be like a let, and we're parsing. Actually, we could see it right here. I'm gonna turn off the lexer. Okay, so now script, we get a let, binding pattern, type annotation, which we don't have support for right now, or it doesn't really do anything. And then we parse the primary expression, parse expression, 16. column 16 expression, primary expression. I should consume this one. No, it's here. Ah, that's the index 16. This is the column 17. Weird though, because no, maybe it's not that weird, because we have, it's like a streaming tokenizing, so we haven't tokenized the rest yet. So we're gonna get the next token, which should be this string here. Hello, what part are you making right now? I'm making string interpolation, the parser. So the tokenizer works. It should work anyway. Actually, you know what? Let's actually check what tokens we get here, because that might be the issue. No, we get like identifier. We get like identifier colon assign start text end. Yeah, that looks good. Okay, so the tokens are fine. It's when we try to read, with like parse the tokens, where things go south. So parse primary expression. Oh, I see. So we should have like a string start. And if we do have a string start, here we go. That's why that's probably why it doesn't work. All right. There we go. Except this needs to be an expression, which we don't have. We don't have this token. Yeah, that's it. Okay. Parse to parse string literal expression was, so it ends there and then it fails. Unexpected expected string start. What? Wait, is it consuming this? Oh, it's consuming the token here. I see. Yeah. So we actually wanna we probably wanna, so all of these wants it to be consumed, but this one actually we don't want to consume it. So maybe we should just peek first. And check if this is equal to string start. Then we return this. What? Oh. Oh, I see. So, okay, well, if there's an error here, we should probably, that should be like this. Or, wait. Yeah. So basically, so okay, this is, you know, I've never actually used this before, but you can do if on a error. Usually what I do is I catch like this p equals stream peak catch whatever error and then do this here, return, and then you can go ahead and use this like this. Okay, this is usually how I do it, but you can also have like this. So if, and this returns an error, but if it's if this succeeds, you will get this value out, and then you can use it in here. But and then you can use like an else, and you can actually, I think you can actually also capture the error here. Yeah, and I use it like this, but I'm not sure what I like more. I think I like this better. Okay, that's usually how I do it. Expected primary tokens. Let's put you here then. And this is not used, so that we don't actually need to use that. You put the tag there. All right. Okay, I think we got maybe further. Oh yeah, we got to the this part now. Cool, so we got our pipeline stage, failed to parse script, unexpected token, expected string end, or string interrupt start. Isn't this string end though? What did you get though? Okay. Expected. Write expected tokens. Failed to parse script. Expected. Print. Wait. Why is that not? Oh. Print. Got. And then some kind of the actual token that we get, that we have. Which token did we get though? Yeah, unexpected token. Expected token. I guess we'll put this here. This is a nullable token tag. And if we get unexpected token, we need to like store fail expected tokens. So we can actually show it. What is this? Parse if. What the hell? Okay, I'll not worry about that for now. So now we can say if unexpected token, we can get that. Oh, wait, to keyword. token description. Ah, there we go. All right. Yeah, so now these need to be... But here we didn't actually get a token, that's the thing. We got an error. So I guess this could be null or, yeah, optional. Here the token was took. Fail expected token. Oh, I see. That's also like a huge part is like building tools to make it easier to debug, and all the tooling is like a huge part of the compiler as well. Let's see. Expect token tag. There we go. Fail expected token. It's gonna be next token tag. How many places do we have? I mean, here we should probably just have a function for this specific pattern, because it's probably pretty, you know, common. Fail expected token. Expect, yeah. So this one we expect the tag, but we got this token instead. This one expected the end. Okay, last one. All right, there we go. Got string interp end. Expected string and or interp as a stack got string end. Okay, so maybe it wasn't consumed. Nope, it wasn't consumed. So I will. Oh, we just consume it here. Okay. There we go. Here's the AST. We got a let declaration mutable false. Binding value is the identifier. We've got the type is skipped. Literal string segment 0 is the text world. Which also means, like right now, you could do hello, and then this into the AST, and it should work. No. Okay, maybe it's because it starts with that. Yeah. Okay, so if we start with, actually I'll make a new tab here. If we start with a interpolation, we actually get an issue. Let identifier colon sign start text and let identifier colon start. Yeah, okay, so it just ends there. What? Okay, it ends here. So there's something weird with the tokens, the tokenizer. What's the language called? Runic. Like this. Oops. Runic. That's the language. No, not token. Parser. Actually. No, so Lexer. There we go. There we go. Let's enable that. Let us go here and see. We get to the string start and then it fails. Okay. So after this, we get to the next. We're in the string context, right? So we should be here. And we're picking, if we have this, we're picking, we should be here. And we shouldn't be at the end because we're just peeking, actually. So all of these we could just remove this. This one we just skip one more. Actually, we should skip two, I think. This one we check if this is that. If it is, we create that. We need to though, do we need to consume it? No. Right, that's why the index doesn't, right. So I think, okay. Index did not increase. I think actually we need to also check. So did index increase? Did context change? So we also need now last context length. Is equal to context stack length. So basically, either the context length should have changed or the index changed. If index did not change and if context did not change, then there's something weird going on. And I'm not gonna bother changing this here. Okay, so now we need to implement that. Whenever we do this, we should also do context length to self context act length. Okay, is that it? Okay, there we go. Okay, let's just start from the start. Let hello colon string assign start text and new line. Let value colon string assign start text interrupt start identifier hello interrupt end straight text hello or world. Okay, yeah, it looks good. Let's do AST. There we are. Here is our AST. We've got a let declaration. Hello is the text hello. We've got the value has 3 segments, so we've got the text. This should really not be a segment, actually, but okay. And then it doesn't really matter that much. And then we have a interpolation with a pipeline that actually it's not a pipeline. Oh, but I haven't implemented. Okay, I haven't actually implemented expressions. So expressions for variables. So that's why this doesn't really. It interprets this as like a executable. It should. Okay, so I think what we need to do in order to fix that is look at the scope. Actually, we're gonna have to look at the scope and see what's in the scope. Maybe. Is that possible at this point? Yeah, that's gonna be something to. Actually, I could put AI to examine that issue and get some ideas for that. But yeah, so this will actually not work now because it's gonna try to run this as a command. But what we could do is not use this. And we could actually do. Oh, hey, it actually understands the command toggle here. But what we could do is do this echo world. This should technically work here. Okay, we just get a pipeline. I haven't implemented printing for the pipeline, so we don't see the AST here. But what about running this? No, that doesn't work. Okay, so that's gonna be interesting to see when that will actually work. But I will just do the normal test here. Yay! Okay, let's disable these things. Hey! It works. Okay, we're back to square one basically. But yeah, okay. That is gonna do it for this time. Probably gonna add like a to-do somewhere here. And I'm going to say just a couple of next things. It's gonna be like well, yeah, that is gonna be the be able to say like values is hello, and then do this. That's the next step. And basically, in order to do that, we just need to parse this as an identifier instead of like a pipeline. So so basically here's gonna be like parser support identifiers as expressions and not pipelines. Maybe through scope to see if the variable exists. Yeah, because that's the thing, like how would you know if it's gonna be a command or if it's gonna be a because technically you could have a command in here as I showed before, like this, but I don't actually have support for that, I guess. But yeah, that's how it's interpreting it right now. So it's interpreting value as a command, and there's no, as you can see here, it doesn't understand what that is. What if we just put echo there? It will probably put like the, no, we get invalid string coercion. Okay. Oh. Can we do like this? No, we don't have parsing for that. Okay, well, anyway, this is probably gonna be interpolated, you know, because this actually evaluates to a process, and then you can actually access like the output of the process, and this is probably gonna interpolate, like coerce this into the out part, standard out part. But yeah, anyway, this is probably gonna be on the next agenda here. So yeah, that's gonna be it for this time. So thank you very much for joining me here, and yeah, I'll see you later. Have a nice day. Bye bye.